you. Very good morning to all of you. And it seems that you are in different mode, very colorful mode. अब मैं सोच रहा हूं कि क्लास को खत्म करके कैसे निकल लिया जाए, क्योंकि आप लोगों की जो अच्छा, यही सारी चीजें बिना देखे मैं इमेजिन कर सकता हूं। ठीक है, तो चलिए फिलहाल तो क्लास कर लेते हैं। तो टुडे वी आर गोइंग टू डिस्कस द वेरी इंपॉर्टेंट टॉपिक, that is what salinity. Then we will come on to the ocean currents. Fine. So in coming year, if UPSC is going to ask some question from ocean current, they are not merely going to ask whether this ocean current is warm ocean current or cold ocean current. They are not going to give you the name, whether it is warm or cold, and what are the impact of this ocean current. Maybe possible they can ask you what is the reason behind it, what is the reason of genesis of this ocean current. So yesterday we discussed about the temperature distribution. I hope you understand. Today we will go for salinity distribution and density distribution, then we will come on to the ocean currents. So it's very important topic. You can expect one major question in your mains examination, and so be prepared for the very important topic. So let's have this. Yesterday we talked about salinity, and we have the discussion that salinity is what? Salt dissolved in water. When salt dissolves in water, it forms solution. This is water, and once you add some salt, so what happened? It forms solution. Okay, so adding some salt, this water has a density, pure water has a density, pure water has a density, and that is 1 gram per cubic centimeter. This is the density of pure water. But what happens if you add some salt of mass m? That means you are adding some extra mass in the same volume. So what happens? The new density, will it increase or decrease? Density is what? Mass distributed per unit volume. This is what the density is. So if you see this mass is going to increase and volume is same, so what happened to density? Density will increase. That means saline water has more density. Saline water has more density. Is it okay to everyone? Saline water has more density. So take down this first statement. Saline water has more density as compared to pure water. As compared to pure water. As compared to pure water. Why there is more density? You understand? There is more density because there is addition of salt, isn't it? There is addition of salt. Okay. Let's find out the factor which is going to affect salinity distribution. Fine. As you all have this idea that this salinity is attributed to the accumulation process of river. So what are the factors affecting salinity? Factors affecting salinity. Factors affecting salinity. The first factor is evaporation. 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 You understand evaporation? That is what? Water turning into vapor phase. Very good. So evaporation at high temperature, there will be more evaporation. At low temperature, there will be less evaporation. This is your pot in which you want to estimate salinity. So if there is high rate of evaporation, what happens? When evaporation takes place, salt is not going with the water. Water is going to be in its purest form. Okay, so only pure water will go up. Pure water turn into vapor. So in vapor, there is only water. And what about salt? Salt is accumulated here. So through evaporation, what happened? Volume is decreasing or increasing? Volume of water is decreasing and mass remains same. So what happened to salinity? It will increase, isn't it? So when there is evaporation, salinity increases. Salinity increases. So take down, evaporation leads to increase in salinity. Evaporation leads to increase in salinity. Is it okay? Evaporation leads to increase in salinity. नहीं, इवेपोरेशन होगा बच्चे तो पानी हटेगा ना. जैसे एक गिलास पानी है, धूप में रख दीजिए, शाम तक थोड़ा कम होगा, अगले दिन थोड़ा और कम, क्योंकि इवेपोरेट हो गया. तो वॉल्यूम विल डिक्रीज. एंड व्हाट अबाउट द सॉल्ट डिसॉल्व्ड इन इट? वो सेम रहेगा, तो सैलिनिटी इंक्रीज करेगी. तो मास किसका आप कंसीडर कर रहे हो? सॉल्यूट का कर रहे हो. जो सॉल्ट है उसका मास कंसीडर कर रहे हो ना. डोंट गेट कंफ्यूज. देयर इज सॉल्वेंट एंड सॉल्यूट. सॉल्यूशन बनता है ना, एक सॉल्यूट है, एक सॉल्वेंट है. सॉल्वेंट इज गोइंग, solute remain there, and solute dissolved in 1000 gram of water is what? Your salinity. And your amount of salt is not going to be altered by evaporation. Evaporation is the surface phenomena. It is only taking the water molecule. So there is decrease in the volume. Is it okay? So there will be increase in salinity. Shall I ask one question? Okay. If you want to compare the salinity of equator 23.5 degree north, 23.5 degree south, or you can say tropic of Cancer and Capricorn. At equator you happen to have 27 degrees centigrade temperature, and at tropic you happen to have 25 degrees centigrade temperature. Where you are going to have more salinity? 0 degree. When I ask certain question, you need to think. What happened at equator, dear? There will be high temperature. Indeed, there will be more evaporation. So what should be the salinity? Salinity should be less. But at equator, you also have this idea, when there is evaporation by 4 p.m., what happened? Rainfall. तो यूपीएससी पूछ सकता है आपसे, पूछ सकता है कि नहीं? कंपैरिजन. सो देयर विल बी इवेपोरेशन, यस, हाई रेट ऑफ इवेपोरेशन, बट रेनफॉल भी तो हो जा रहा है. तो विल फाइंड एवरेज सैलिनिटी ओवर हियर 35 to 37 parts per thousand. And what happens here? At this much rate, there is evaporation but no rainfall, or less rainfall. So you will find 41 to 42 parts per thousand. 41 to 42 parts per thousand. This is going to be the salinity. That means in open water, in huge ocean, you will find equatorial salinity is going to be less. Why? Because there is evaporation indeed, but evaporation followed by rainfall. Is it okay? And what happened to the polar region? In polar region, there is a less rate of evaporation. So there will be less salinity. And apart from that, other factors are also going to play a role, like addition of fresh water. Isn't it? So you take down the salinity distribution, evaporation increase the salinity at equator, there is high rate of evaporation followed by rainfall. There is high rate of evaporation followed by rainfall. High rate of evaporation followed by rainfall. Hence, salinity remain average, and that is 35 to 37 parts per thousand. 35 to 37 parts per thousand. Near the tropics, there is high rate of evaporation hence salinity remain higher. Salinity remain higher. Hence salinity remain higher. ठीक है, salinity remain higher. Okay. In polar region, there will be less insolation, less temperature, low temperature, hence lower rate of evaporation. That's why average salinity remains 20 to 30 parts per thousand. 20 to 30 parts per thousand. Apart from it, in polar region, melting of glacier give fresh water an addition of fresh water क्या करेगा? Will decrease the salinity. Will decrease salinity. Second factor is what? Addition of fresh water. क्या बेटे? हाँ, 20 to 30 average salinity of polar region water is 20 to 30. Okay. और बहुत जगह तो बहुत कम है, जैसे बोथीनिया की खाड़ी में, if you see the Gulf of Bothnia, you will find it is 2 parts per thousand to 11 parts per thousand. It varies. Actually, salinity has so many factor that is going to affect it. Salinity जब ऑप्शनल में पढ़ाते हैं तो 3 क्लासेस लगती हैं, है ना? Region wise salinity, there means if you talk about open ocean, its salinity has some factor which is going to affect. When you see partially opened ocean or partially closed ocean like Mediterranean Sea, Red Sea, वहां की salinity को फैक्टर को और भी फैक्टर होते हैं जो कि अफेक्ट कर सकते हैं. Enclosed landlocked ocean in tropics, landlocked ocean in higher latitude, rate of evaporation will change. Landlocked ocean with river discharge, the Black Sea है, Caspian Sea है, with river discharge, without river discharge, जैसे Dead Sea है, Salt Lake है ना, Lake Van, इसमें कोई river discharge नहीं है, and there is huge evaporation at high temperature, salinity 238 parts per thousand, this much salinity you will find. So there are many factors, but in general study we just focus on some major factor and some major, what you can say, known water bodies and its salinity you should have in your mind. Okay, I'm just giving you the crux of the entire salinity. Salinity topic goes for 3 days, means at least 7 to 8 hours needed to discuss all those factors. But I'm giving you the general perception of a factor affecting salinity, isn't it? So according to that, means in polar region, you have 20 to 30 parts per thousand salinity. In which ocean? The open ocean, isn't it? If it is going to be closed, if it is going to be landlocked, partially landlocked, then salinity has some different connotation, and there are some other factor responsible for bringing the salinity into that very water body. Okay. Addition of fresh water. It can be done by 3 ways. One is rainfall. So if there is rainfall, so obviously there will be addition of fresh water. Rainfall, the water is what? In purest form, there is no solute inside the rainwater. Second one is melting of glacier. Melting of glacier. And the third one is massive river discharge. Massive river discharge. Will it affect salinity or not? Answer is yes. Addition of fresh water, that means you are having some salinity, and there is the addition of some fresh water that is taking place. Suppose that this is your water body in which you happen to have some salinity. This is the volume of water V, and it is containing mass m salt. And if there is addition of fresh water in form of any river, the discharge, what happened? Volume of water will increase or not? So salinity will decrease. If there will be rainfall, what happened? Indeed, there will be addition of fresh water. Or if melting of glacier is taking place. So as in case of polar salinity, you have seen that there is melting of glacier that is taking place, and due to that the average salinity is going to be less. Is it okay? For example, where rainfall is going to decrease salinity, we have discussed in equatorial region. Equatorial region, there is high rate of evaporation, but followed by rainfall, 4 p.m. rain. Is it okay? So if there is 4 p.m. rain, so all the water which goes up comes down. So there will be average salinity. Melting of glacier, you have seen in case of polar water. Polar water, isn't it? And what about massive river discharge? Remember 2 places. I'm just putting it on the map, and it will help you to understand the ocean currents also. So there is a river, Mississippi, Missouri. Mississippi, Missouri. Basically, this part has to be little bit. Okay. So this is the place of Mississippi, Missouri. Mississippi, Missouri river draining its water over here. Massive river discharge. This is the largest river of North America. And the place is what? New Orleans. New Orleans. And there is another river that is what? Amazon. So we'll find Amazon discharge. And in the equatorial region, you will find many huge river like Congo is there and so many river, they are discharging water. And this is what? Fresh water. It is freshwater discharge. Indeed, there will be some salt, but it is not saline water, freshwater discharge. So addition of these water will decrease salinity, will decrease density of water also. Yes or no? If low salinity will be there, water density will decrease. And lighter water will float in form of surface current. Lighter water, less denser water will float on more denser water. More denser water tend to sink and lighter water tend to flow in form of surface current. So we'll find one current generated over here. From here, it start moving like this. And there is another current generated. One is Florida current. Florida current. And you have Antilles current. So Florida current, why generated? Because of the Mississippi, Missouri discharge. Because of this discharge, what happens? Salinity get decreased. And nearby area salinity is more. So more saline water will be denser water. It will subduct. And less saline water will float in form of surface current. So there will be a current generated from Florida, means from New Orleans moving towards Florida Peninsula, and it is termed as Florida current. Is it okay? So why the Florida and Antilles current are generated? Because of the salinity difference. How this salinity difference brought? Because of the freshwater discharge. Likewise, you will find here, there is this is your Greenland, you remember? And you will find one cold current coming over here. What is the name? Labrador current. So this Labrador current, cold or warm? Cold current बच्चे, जो भी पोल से इक्वेटर की ओर आए, they all are cold current. Why this current was generated? Because of melting of glacier. Glacier melt होगा बच्चे तो क्या होगा? There will be addition of fresh water. Addition of fresh water. Fresh water will be what? It will be less denser water, lighter water, and lighter water floats in form of ocean current. Is it okay to everyone? You understand? तो Labrador current क्यों generate होती है बच्चे? Because of melting of glacier and addition of fresh water. Isn't it? You understand? Why current floats? Because of the difference in the level of the water. Level of the water. Indeed, density will decide. Temperature will also decide. But level of the water will be there. If higher level will be there, certainly current start flowing from higher to lower area. I will come on that. Fine. So you understand? Second factor which is going to reduce salinity, addition of fresh water in equatorial region, rainfall, melting of glacier. For example, we discussed Labrador Sea, and massive river discharge. We have Antilles current as an example, or Florida current as an example. They are flowing because of the reduction in salinity. Is it okay? So addition of fresh water will reduce salinity. Fine. लिख लीजिए. Addition of fresh water reduce salinity. Reduce salinity. It is due to rainfall, melting of glacier, and third, massive river discharge. Massive river discharge. Massive river discharge. Lower salinity results low density water become lighter water, and lighter water floats in form of surface current. That means if you have the spot, consider this spot, I have a water having salinity S1, there is a salinity S2, keeping other factor constant. I want to ask, if S1 is higher salinity, higher saline water, higher salinity, and S2 is having lower salinity, from where to where water start moving? You understand? And don't put osmosis, because this is not the semi-permeable membrane, है ना? नहीं तो गलत हो जाएगा. साइंस में osmosis कुछ लोग लगाएंगे. हाँ. Yes, I said keeping other factor constant. There are some major factor, much more than bigger factor for driving the ocean water. I will tell you. But keeping other factor constant, if salinity is like that, lower salinity, that means lighter water. Lighter water, that means it will float in form of surface current. Higher salinity means more density. Isn't it? That means heavier water tend to sink and lighter water tend to. So you will find the ocean current moving from lower salinity to higher salinity. Is it okay to everyone? Lower salinity to higher salinity. But yes, salinity difference, temperature difference, these are the feeble factor. Somewhere they are going to be dominant, but most of the time other dominant factor for the movement of ocean water is going to be there, like Coriolis force, rotation of earth. These are the dominant factor. I'm coming on that. But you understood salinity, isn't it? Let's find out the salinity distribution. So if you see the salinity distribution, horizontal salinity distribution, there are many factors which is going to be accountable. Many factors. So when they are asking some salinity distribution, I don't think that they should ask question on salinity distribution, but even then, if they ask, they will put some important major known water bodies. Fine. So if you see the horizontal salinity distribution, and we are talking about open ocean, like Pacific Ocean, Atlantic Ocean, Indian Ocean. In that case, we have already read that in equatorial region, average salinity is going to be 35 parts per 1,000. While in tropical region, tropical ocean, you will find it is 41 to 43 parts per 1,000. And in polar region, there is 20 to 30 parts per 1,000. That means if we consider tropics as an exception, you will find that average salinity is decreasing while moving from equator to ना। ट्रॉपिक्स एक एक्सेप्शन मान लिया जाता है, क्योंकि खास करके जो वेस्टर्न मार्जिन है कॉन्टिनेंट की, वहां पे सैलिनिटी थोड़ी ज्यादा होती है ईस्टर्न मार्जिन की अपेक्षा। ठीक है, कॉन्टिनेंटलिटी इफेक्ट, वेस्टर्न मार्जिन पे कॉन्टिनेंटलिटी इफेक्ट होता है। ईस्टर्न मार्जिन you happen to have rainfall also. At western margin, scanty rainfall. You understand? In case of open sea, in case of partially landlocked sea जैसे मेडिटेरेनियन, है ना, इसको लिख लिया, लिख लीजिए। In case of partially landlocked sea, like Mediterranean Sea, Red Sea and Persian Gulf, Mediterranean Sea, Red Sea and Persian Gulf, तीनों को कंपेयर करते हैं बच्चे। मेडिटेरेनियन सी, रेड सी एंड पर्शियन गल्फ। एवरेज सैलिनिटी 37 to 41 पार्ट्स पर थाउजेंड, 37 to 41 पार्ट्स पर थाउजेंड। (37 to 41) एवरेज सैलिनिटी ऑफ ब्लैक सी। ब्लैक सी देख रहे हो? एक बार एटलस भी खोल लो, एटलस भी ओपन करो। ओपन किया, मेडिटेरेनियन दिख रहा है, मेडिटेरेनियन सी, फाइन। रेड सी दिखा क्या? देखो अफ्रीका और अरेबियन प्लेट के बीच, और पर्शियन गल्फ देखो अरेबियन प्लेट और यूरेशियन प्लेट के बीच में, देखा ना। रेड सी के पास आपको एक स्ट्रेट भी दिख रहा होगा, बब अल मंदब, देयर इज हॉर्मुज, देख लिया स्ट्रेट। दीज आर द मेजर ट्रेड रूट्स, है ना। इंडियन ओशन जियोपॉलिटिक्स तो पढ़ा होगा ना अपने PSIR में, पढ़ा है, पढ़ेंगे आगे। मैं भी उसका ज्योग्राफिकल पर्सपेक्टिव आपको दे दूंगा, ठीक है। So now see the Mediterranean Sea, it is connected through Atlantic Ocean. From one way it is Strait of Gibraltar, Strait of Gibraltar. Try to see Iberian Peninsula, entry point of Mediterranean Sea. देख लिया बच्चे, दिस इज योर मेडिटेरेनियन सी, हियर इट इज स्ट्रेट ऑफ जिब्राल्टर, स्ट्रेट ऑफ जिब्राल्टर। Here you will find Suez Canal, Suez Canal. Suez Canal. Then this is what? Red Sea. Is it okay? Red Sea. And then another strait you will find over here. What is the name? Bab al-Mandab. And this is your Persian Gulf. Persian Gulf. Is it okay? Connected with Arabian Sea, Strait of Hormuz. And I said these are the trade route as well as choke points like Strait of Hormuz and Bab al-Mandab, because this Suez Canal is connecting Mediterranean to Red Sea to Indian Ocean, then Western Pacific Ocean, isn't it? Western Pacific countries also. And from here we are connected through Atlantic Ocean to North America as well as South America. Because of this Suez Canal, what happened? ये पहले रास्ता ये था केप ऑफ गुड होप से जाने का, तो काफी लंबा रास्ता होता था, तो इसके बनने से क्या हुआ, ट्रेड रूट ये हो गए. ओके, नाउ वी आर डिसाइडिंग द सैलिनिटी. दिस इज योर इक्वेटर, ट्रॉपिक ऑफ कैंसर, ट्रॉपिक ऑफ कैप्रिकॉर्न. So this Mediterranean is in temperate region. In temperate region, what happened? There will be low evaporation, less temperature, na? So you happen to have low evaporation. So what should be there? Salinity, higher salinity. That's why the average salinity is 35 to 41. Why it is 37 to 41? Because it is landlocked also. Landlocked है ना, open sea नहीं है, landlocked. Is it okay? Further, in Red Sea also, and same you will find in Persian Gulf. Although in Persian Gulf you will find two river. कौन कौन सी? Persian Gulf में दो river कौन सी हैं? Tigris and Euphrates. Between Tigris and Euphrates plain, you happen to have Mesopotamia civilization. Okay, so that is over there. Further, Black Sea. Try to see Black Sea. Black Sea has average salinity of 18 parts per thousand. Black Sea. Black Sea. Average salinity 18 parts per thousand. Try to see the Black Sea region. देखो जरा. अच्छा, इतना कम क्यों है? Because there is river discharge, massive river discharge. If you see Black Sea, you will find Don, Dnieper. These are the river. Please take down Don, Dnieper, Danube, Don, Dnieper, Don, Dnieper, Danube. These are the three rivers draining into the Black Sea, and due to that, what happened? The Black Sea has addition of fresh water will cause what? Less salinity, isn't it? आपके दिमाग में एक चीज आ रही होगी, क्या? हाँ, बहुत अच्छा, अच्छी बात है कि आपके दिमाग में ये बात आई. At one place, sir is saying that these rivers are the main culprit of this salinity, and in other place, I'm saying that there is low salinity because of river discharge. So what is right? Indeed, it should be a question. So this is what? Fresh water. Fresh water having some salt, but it is not saline. Pure water, fresh water, and brackish water, saline water. 4 waters you are going to have. One is pure water. Pure water that is containing no salt, isn't it? No salt. Pure water. For example, which water is pure water? Yes, rainwater. Rainwater, water from melting of glacier. Immediately, this glacier water is also going to be pure water. What about fresh water? Fresh water. Fresh water contains some amount of salt. Fresh water contains some amount of salt. And how much salt it is having? It is having 5 parts per thousand to 17 parts per thousand. 5 parts per thousand फ्रेश वाटर पीते हैं तो आपको मीठा लगता है, और थोड़ा ज्यादा है तो वो खारा पानी लगता है, तो उसके लिए आप आरओ लगाते हैं। ठीक है बच्चे। तीसरी कैटेगरी होती है बच्चे ब्रैकिश वाटर। ब्रैकिश वाटर, इसको ये 17 मत करो, दिस इज व्हाट 10, दिस इज 10 पार्ट्स per thousand. Brackish water. This brackish water is from 10 parts per thousand to 18 parts per thousand. ये brackish water की कैटेगरी। And what about saline water? Saline water. Saline water is 18 parts per thousand to more. This is what you have, the saline water, है ना? So brackish water, saline water, fresh water and pure water. Here this river is bringing fresh water, that means it contains some salt, and this river is bringing this tiny amount of salt since time immortal. That means it is accumulating process of the river. River have accumulated this salt for the time immortal. Every time it is bringing some salt, giving the water body, and the salt is accumulated day by day. Today's salinity is because of the accumulation. But what about instantaneous salinity? If you see, this water certainly have lower salinity as compared to this water. Certainly have. So in the delta region, you'll find the brackish water. In the backwaters, the tidal water is going to be brackish in nature, less saline. It is not as saline as ocean water. Is it okay? So river is responsible for salinity, but this is for accumulation process. It has accumulated since time immortal. Then the salinity, average salinity of ocean is like that. But if you see instantaneously, it is draining water, so it is adding fresh water. An addition of fresh water will reduce the salinity. So यहाँ की salinity is what? Lower as compared to the average salinity of this water. This is for sure. Why? Because it is immediate. Is it okay? So that's why we are discussing this Black Sea salinity, why it is so low. Because of Don, Danube, Dnieper, they have accumulated this salinity since time immortal, but because of freshwater discharge, it is not as high as the tropical as well as equatorial salinity. In equator, where you will happen to have more river, आपको रिवर सबसे ज्यादा कहां मिलेंगे? जहां पे ज्यादा आसपास में लैंड होगा। चलिए राजस्थान में देखते हैं। आप अगर प्लम्बर होते तो पाइपलाइन कहां बिछाते? जहां पानी का ड्रेन बनाना होता है, यानी पहली रिक्वायरमेंट है जहां रेनफॉल ज्यादा होती। आप देख लीजिए जितनी भी मैसिव रिवर हैं, दे आर इन द इक्वेटोरियल रीजन। व्हाई दे आर देयर? जो नेचर भी प्लम्बर है ना, उसने अपना सही जगह चुना कि भाई यहीं पे हमें ज्यादा बारिश होगी तो यहीं रिवर होनी चाहिए, तो मैसिव रिवर उधर है, तो उनका डिस्चार्ज मैसिव है, तो वो सॉल्ट भी ज्यादा लाएंगे। ठीक है, एंड द सॉल्ट इज स्लोली एंड ग्रेजुअली इज गोइंग टू बी पार्ट ऑफ व्हाट? सैलिनिटी। ओके, so in equatorial region there is low salinity, little bit low salinity because of addition water, and in tropical region there is high salinity because of no water added up. In equatorial region you have rainfall along with massive river discharge, isn't it? That's why you happen to have 35 parts per thousand. In this case you are going to have no evaporation, low rate of evaporation, and along with that fresh water discharge, so collectively there is 18 parts per thousand salinity. Is it okay? इससे ज्यादा जीएस में नहीं जाते, अदरवाइज देयर आर सम मोर फैक्टर जो कि मैं डिस्कशन में नहीं लाना चाहता। आगे लिख लीजिए, salinity of Baltic Sea. एवरी टाइम इंक्रीज इन एवरेज सैलिनिटी। इस पानी में आपने नमक घोला, ये सॉल्यूशन बनेगा बच्चे, तो चारों तरफ सैलिनिटी एक जैसी होगी, होगी कि नहीं? वो एवरेज सैलिनिटी है। वो किस कारण से हुई है? बिकॉज ऑफ एक्यूमुलेशन। बट अब यहां पे अगर ये मान लो इतना भरा रहता और यहीं मैं पानी डालने लगता, तो जहां पानी गिरता वहां की एवरेज सैलिनिटी बाकी के सैलिनिटी से कम होती या ज्यादा? कम होती, क्योंकि आई एम एडिंग फ्रेश वाटर। दिस इज व्हाट टू अंडरस्टैंड। The river has increased the salinity since time immemorial. It is accumulation process of the river for, yes, crores of years, isn't it? And instantaneously you are watching this water is having what salinity. So where the mixing of fresh water and saline water will be there, obviously the resultant is going to be brackish water. Are you getting my point? But yes, fresh water is adding some amount of salt. It will increase the average salinity of entire water. But near the estuary or near the delta, you are going to have brackish water. Do remember. Is it okay? Fine. In case of Baltic Sea, the average salinity is from 2 to 11 parts per thousand. 2 to 11 parts per thousand. Baltic Sea, and it is due to melting of Scandinavian shield, melting of Scandinavian glacier. Scandinavian glacier. There are many tiny streams adding fresh water to it. ठीक है बच्चे? Let's talk about landlocked sea. Landlocked sea, like Great Salt Lake. Please take down landlocked sea. Landlocked sea. For example, Great Salt Lake, Dead Sea, Lake Van, Great Salt Lake. कहां पे है बच्चे? यूएसए का एक स्टेट है यूटा, जहां पे आपको ग्रेट सॉल्ट लेक मिलेगा. डेड सी, you'll find जॉर्डन, सीरिया, इजराइल. बड़ा इंपॉर्टेंट एरिया है बच्चे, लोकेशन के पॉइंट ऑफ व्यू से देखना है उसको भी. तो यू विल फाइंड डेड सी ओवर देयर. एंड देन लेक वॉन, it is in Turkey. If you see their salinity, it is humongously high, very high salinity. Like in Great Salt Lake, you happen to have a salinity of 220 parts per thousand. Great Salt Lake, 220 parts per thousand. 220 parts per thousand. Dead Sea, 238 parts per thousand. And what about Lake Van? It has the highest salinity, 338 parts per thousand. And these are the highest range of salinity. You will find that there is massive evaporation taking place. Massive evaporation. So high rate of evaporation, and there is very few drainage that has given the salt. High rate of evaporation, and due to that you will find that there is very high salinity. They are the landlocked sea. and comparing these landlocked sea with Caspian Sea. There is another landlocked sea. Can you see Caspian Sea? देखो जरा. कैस्पियन सी देख लिया. अच्छा, कैस्पियन सी लैंडलॉक्ड है कि नहीं बच्चे? लैंडलॉक्ड. तो क्या लगता है आपको, इसकी सैलिनिटी ज्यादा होनी चाहिए, बहुत ज्यादा होनी चाहिए, कैसी होनी चाहिए? ज्यादा होनी चाहिए, लैंडलॉक्ड है. अच्छा, इसकी सैलिनिटी मैं बता दे रहा हूं बच्चे. द सैलिनिटी इज इन बिटवीन 17 to 18 पार्ट्स पर 1000. ये लो सैलिनिटी है या हाई? लो. रीजन क्या है बच्चे? देखो, ध्यान से देखोगे ना, यू विल फाइंड टू मैसिव रिवर. मैसिव रिवर, वन इज यूराल, another one is Volga. Volga and Ural, these two rivers are draining into the Caspian Sea. देख लिया वोल्गा और यूराल. देखो, यूराल माउंटेन दिखेगा और वहीं से एक रिवर आ रही है, कैस्पियन सी में ड्रेन हो रही है. यूराल एंड वोल्गा, यूराल एंड वोल्गा. Is it okay? So we have some. देख नहीं पाए क्या? यूराल एंड वोल्गा. हाँ, क्या चीज? ओरिजिनेट यूरोप, नॉर्दर्न यूरोप. रशिया वाला पार्ट देखो ना, मिला? ठीक है, चले आगे. अच्छा, लेट्स फाइंड आउट द vertical distribution of salinity. Vertical distribution. Vertical distribution of salinity. Again, we will go through the same way as we have seen in case of temperature. There will be epilemnion. This is the sea surface. Here it is 300 meter level, epilemnion. Then 1000 meter level, 1000 meter level. That is called as transition zone. And then you have deep sea. Deep sea. Fine. And for salinity, we will not quantify salinity because we have so many changes. So we can put like this: low salinity here, and there will be high salinity. Okay. Low salinity and high salinity. What happened to the salt? The salt dissolve first in upper layer, and there is upper layer that is continuously mixing with each other because of the wind, because of the ocean currents and all. Slowly and gradually this salinity percolates down, isn't it? And in lower water you happen to have constant average salinity. The lower water, the deeper water has constant average salinity, and in this transition zone you will find massive decrease in the salinity. Is it okay? So you will find higher salinity in this region, but if we have three water, one is polar water, another one is tropical water, and equatorial water. So in equatorial water, we will start somewhere like here, 35. If we see this tropical water, we will start near 42, for example. And what about polar water? There will be 20 to 30, let's take up 25. This will be the starting point. So if you see the highest salinity, where you will find highest salinity? Tropical water. So the highest salinity will decrease like this. So in upper water there is less decrease, but once you are in transition zone, the decrease is going to be massive. It is not that much. There will be decrease, but yes, this decrease is like this. And then there is a constant salinity you will find in deep water. Deep ocean water of entire earth is going to have constant salinity because water is connected with each other. Is it okay? So you will find this kind of graph. In which water? It is in tropical water. This is in tropical water. Tropical water has higher salinity. Yes. And there is a massive decrease in salinity from 300 meter to 1000 meter. And this zone is called as halocline. Halocline. Isn't it? Just like thermocline, there is a massive decrease that is called as halocline. ठीक है बच्चे? Halocline. And then there is a constant salinity. ठीक है बच्चे? In deep water below 1000 meter, you happen to have same salinity, whether it is tropics, equator, or pole. Fine. So let's talk about equatorial salinity. It is also going like this. So you'll find this is going to be halocline. So halocline well developed in which water? Tropical water. वहां क्या था? Equatorial. ध्यान रखिएगा. And this is what the water of equatorial water salinity. We are talking about salinity. Is it okay? And what about pole? Near pole, the surface water has considerably high salinity, 20. And the average salinity of total water is what? Lower than the polar water also. ये लगभग 16 to 18 parts per thousand होता है बच्चे. Isn't it? So the starting point will be from here. There will be decrease in salinity, and then what happened? Increase in salinity, and this is going to be the graph. Isn't it? And this, suppose that this is what? Polar water, na? This is your polar water. So in polar water, you happen to have a little bit increase in salinity from the surface. In lower area, you have little bit increase in salinity. Then further what happened? Decrease in salinity, and you will have constant salinity in the deep water. So polar water has a halocline like this. Is it okay? If I ask one question, this constant salinity after 1 crore year from today, what will happen? It will increase or decrease? From today means आगे जाते जैसे जैसे समय बीतेगा ये salinity increase होगी या decrease होगी? क्यों? क्योंकि there is continuous. You understand? So do remember, this is what? Vertical distribution of salinity. Is it fine? Vertical distribution of salinity. Is there any query? ये क्या हो रहा है पहले ये बताओ. पोलर वाटर में यहां पे 20 to 30 है, एवरेज हमने ले लिया इसका 25 पार्ट्स पर थाउजेंड. मैंने बताया लोअर वाटर कनेक्टेड होता है, तो लोअर वाटर में यहाँ पे आप देख रहे हो सैलिनिटी का रेंज कितना है, हायर एरिया में है, यानी लोअर वाटर में सैलिनिटी क्या होगी? थोड़ी अधिक ही होगी. ठीक है, लेकिन उससे नीचे वाले वाटर में सैलिनिटी डिक्रीज हो रही है, तो यहाँ डिक्रीज होगी. ये मुझे और इधर बनाना चाहिए था, है ना? इन लोअर वाटर देयर विल बी फर्दर डिक्रीज. So you'll find halocline developed in, especially in case of tropical water, it is well developed. Halocline, that is the gradient of salinity which is going to be higher between the zone of 300 to 1000 meter. Is it okay to everyone? हाँ, पूरा से नहीं इंक्रीज हो जाएगा. मैंने कहा कि ये जो एवरेज सैलिनिटी यहाँ है, हाँ हाँ, मैंने कहा कि अगर 1 महीने बाद भी ये सैलिनिटी देखोगे तो पहले से थोड़ा इंक्रीज होगा कि नहीं, ये पूछना था, क्योंकि स्लोली एंड ग्रेजुअल। बायोस्फीयर कहां तक है बच्चे? क्या एवरी पार्ट ऑफ हाइड्रोस्फीयर इज हैविंग बायोस्फीयर? एवरी पार्ट ऑफ एटमॉस्फेयर इज हैविंग बायोस्फीयर, और एवरी लिथोस्फीयर इज हैविंग बायोस्फीयर? फिर वही बात पूछ रहा हूं ना कि तुम्हारा बायोस्फीयर कहां तक एक्सटेंड करता है हाइड्रोस्फीयर में? डीपर वाटर में क्या बायोस्फीयर है? तो क्यों ऐसी बात पूछ रहे हो? आपका जो बायोस्फीयर है वो सरफेस पे है या कुछ गहराई तक मिलता है, लेकिन इन डीप वाटर एक्सेप्ट द हाइड्रोथर्मल वेंट्स बैक्टीरिया यू आर नॉट गोइंग टू हैव सम, मींस मोर बायोडाइवर्सिटी इज नॉट देयर. Whatever the biodiversity is acclimatized for that very condition. No, it will not. ठीक है? So lower water, it's not like कि इतनी जल्दी हो जाएगा, but the question is कि what is the fate of this constant salinity? It will increase, it will never decrease. That means 1 करोड़ साल पहले ये constant salinity थोड़ी कम रही होगी, आगे और बढ़ेगी. क्यों? क्योंकि नदियां क्या कर रही हैं? एक्यूमुलेट कर रही हैं, एक्यूमुलेशन कर रही हैं. इज इट ओके? लेट्स टॉक अबाउट द मूवमेंट ऑफ वाटर. मूवमेंट ऑफ वाटर, ठीक है बच्चे? और इसमें हम लोगों को ओशन करंट पढ़ना है. ओशन करंट, okay, ocean current, and there are many factors which is responsible for ocean current. Before that, I would like to ask one very simple question to start this topic. Suppose that this is the water body and let's have an imaginary division over here. This is area A, here it is area B. In area A, you happen to have high temperature. In area B, you have low temperature. Is it okay? I'm just putting one question for you. So high temperature, what will happen to pressure? Low pressure. And low temperature, what will be the pressure? High pressure. Is it okay? My question is, movement of water taking place from A to B or B to A, and why? कितने लोगों ने कहा B to A? और कितने लोगों का मानना है कि A to B? और कितने लोग ये कहते हैं कि भाई कोई मूवमेंट नहीं होगा, नो मूवमेंट? एंड कितने लोग कहते हैं कांट बी प्रेडिक्टेड? हाँ, बहुत ध्यान से सुनना. यहां से तुम्हें यह पता चलेगा कि वाटर के मूवमेंट के लिए व्हाट आर द मेजर फैक्टर एंड व्हाट आर द माइनर फैक्टर. हाउ मच ऑफ यू सपोर्टिंग B to A? 1 2 3 4 5 6. व्हाट अबाउट A to B? अच्छा, जो लोग B to A कह रहे हैं वो क्यों? हाँ, इवेपोरेशन कम है तो सैलिनिटी डिक्रीज होगा. सैलिनिटी डिक्रीज होगा तो फ्रेश वाटर ज्यादा होगा. ठीक है? यहां सैलिनिटी, लो सैलिनिटी है और वहां हाई सैलिनिटी है. अच्छा, हाई टेम्परेचर, वहां हाई सैलिनिटी आपने कर दिया इवेपोरेशन के कारण. वेरी गुड. कितने लोगों ने, ये आप किसके सपोर्ट हैं? A to B वाले ना? अच्छा, B to A, फाइन. इन्होंने सैलिनिटी को आधार बनाया. आपने क्या आधार बनाया सर? टेम्परेचर से हवा चलाई थी, हाई प्रेशर टू लो प्रेशर, ये नीतीश कुमार है। अच्छा सोचना है, देखो ये दिस इज अ क्वेश्चन, दिस विल गिव यू सो मेनी इन्फरेंसेस and from here we will understand which is going to be the major factor that is causing movement, whether it is salinity, temperature difference, pressure difference, wind or something else. हाँ बताइए, A to B, हाँ बताओ A to B कैसे, देख पहले एक पे टिक जाओ, गड़बड़ हो गया। अच्छा तुम क्या चाहते हो, विंड मूवमेंट B to A होगा, तो विंड विल ड्रैग इट एंड टेकिंग इट टुवर्ड्स दैट साइड। अच्छा ठीक, विंड मूवमेंट, हाँ आप बताएं। ऐसा कुछ नहीं है, टेकिंग अदर फैक्टर कांस्टेंट नहीं है, देयर आर ऑल द फैक्टर, यू आर इन नेचुरल सेट ऑफ कंडीशन। Then why I am putting this question in front of you, कि once you are in natural set of condition, तो you have to prioritize the forces ना, कि कौन सा फोर्स सबसे ज्यादा डोमिनेंट हो। अच्छा ये बताओ, यहां से मैं एक टंकी रख दूं बड़ी सी ऊंचाई पे, और उधर तुम्हें दे दूं फर्राटा वाला पंखा, फर्राटा समझते हो ना, जो जोर से चलता है, उधर से हवा तुम चला दो, और मैं इस टंकी को फाड़ दूं और तुम्हारी तरफ ही ढलान हो, तुम फर्राटे से हवा चला के रोक लोगे पानी क्या? अगर ऐसा होता तो डैम टूटता वहीं लगा देते कि ब्लोइंग विंड वापस कर दे। तो पानी को मूव करने के लिए सबसे ज्यादा जरूरी क्या है? फ्लो, ग्रेडियंट। इफ ग्रेडियंट विल बी देयर, इट इज गोइंग टू बी द डोमिनेंट फैक्टर। इज इट ओके? तो देखो, जिनको ये विंड समझ में आया ना कि हाई प्रेशर लो प्रेशर, इसीलिए मैंने बताया प्रिवेलिंग विंड कैन ऑल्सो कॉज मूवमेंट ऑफ वाटर, बट व्हेन अदर फैक्टर आर नॉट वर्किंग और अदर फैक्टर आर मॉडरेट। लेकिन जहां पे तल में अंतर हो गया ना बच्चे, तलांतर, लेवल में डिफरेंस हुआ, वहां पे पानी मूव करेगा, कोई रोक नहीं सकता। दिस इज फॉर श्योर। अब तल में अंतर कैसे हो रहा है देखते हैं। When there will be high temperature, what will happen? Thermal expansion. Thermal expansion होगा बच्चे, तो पानी क्या करेगा? एक्सपैंड करेगा। और लो टेम्परेचर है तो थर्मल, पानी कहां जाएगा? तल में अंतर दिख गया, ये सबसे बड़ा फैक्टर होता है। ठीक है, अब तुम कितनी भी हवा चला, अगर तल में अंतर है तो कहां से कहां पे? पक्की बात। सो व्हाट इज द डोमिनेंट फैक्टर? डिफरेंस इन लेवल। अगर लेवल सही है तब फिर विंड कहेगी हम भी बहा ले जाएंगे, तब फ्रेश वाटर एडिशन भी कुछ कर ले जाएगा। लेकिन अगर लेवल में अंतर है तो फिर तो पानी अपने मन से जाएगा। समझ गए? सो वाई आई केप्ट दिस क्वेश्चन कि विच आर द फैक्टर विच इज गोइंग टू बी डोमिनेंट, एंड देयर आर सम मेजर फैक्टर, डोमिनेंट फैक्टर, some minor factor and modifier factor which is responsible for ocean water movement. Indeed, prevailing wind is one of the cause. Prevailing wind, if going to be very strong, like in northern Indian Ocean, it is going to reverse the gyre of oceanic current, but provided we have the same level. If level is going to vary because of thermal expansion, thermal contraction, second because of density difference, third because of salinity difference, certainly water will move in form of surface current from higher level to lower level. Is it okay? So let's find out ocean current and those factor. ठीक है, ये बस आपकी mental exercise के लिए था, so that you get open for all those discussion. ठीक है, ocean current. What do you mean by ocean current? Ocean current is just like river flowing in upper water. Upper water. What does it mean? Up to 400 meter water. This is what called as upper water. And hence ocean currents are called as surface current. Surface current. Okay. So what is ocean current? It is the surface current moving from one place to other place in form of river inside the ocean. This is the definition. And what about the surface current? Surface current is what? Upper water current is called as surface current. So if you have this water body, so there will be depth, and this depth is just 400 meter. And this 400 meter above water, if moving, then it is going to be called as surface ocean current. So movement in this water constitute surface ocean current. This is the movement. Whatever the reason is there. So this surface current, it is also called as surface current. And if you see the circulation of ocean, surface current is only responsible for 10% of total oceanic circulation. It accounts for 10% of total oceanic circulation. And rest of the 90% ocean circulation belongs to नाम याद रखना, डीप ओशन करंट. डीप ओशन करंट जो आपके कोर्स में नहीं है. आने वाले समय में इस पे खूब सारे आर्टिकल आने वाले हैं. क्योंकि डीप ओशन करंट इज रिस्पॉन्सिबल फॉर सो मेनी चेंजेस इन द सरफेस वाटर. है ना, अपवेलिंग बताया था ना, कहीं अपवेलिंग होगी. इसके बारे में कम पढ़ना है आपको जीएस में. ठीक है. डीप ओशन करंट, 90% of oceanic circulation attributed to deep ocean current. Only 10% is what? In form of surface current. Is it okay? Further distribution of this ocean current is on the basis of temperature. Warm ocean current and cold ocean current. हाँ. Definition लिखिए. Ocean current is just like river flowing in upper water of ocean. Just like river flowing in upper water of ocean. Upper water of ocean. They are the surface current. They are the surface current. In case of surface current, in case of surface current, in case of surface current, 400 meter upper water, 400 meter deeper water, not upper water, 400 meter deeper water has been taken into account. Has been taken into account. ठीक है बच्चे? Has been taken into account. The surface current constitute 10% of surface current constitute 10% of total oceanic circulation. Total oceanic circulation. Total oceanic circulation. Below 400 meter, the ocean currents are called as deep ocean current. deep ocean current that constitute 90% of oceanic circulation. ठीक है? So on the basis of depth, again we have surface current and deep ocean current. Two definitions. You understood? 400 meter is what? Limit of surface current. On the basis of temperature as well as the origin, we can divide the ocean current into two groups. One is what? Warm ocean current and cold ocean current. Warm ocean current, warm ocean current ocean current moving from equator, moving from warmer region, not always equator, moving from warmer region to colder region. Warmer region to colder region, they are termed as warm ocean current. Warm ocean current. Generally इसको अंडरलाइन करना लाइन. Generally ocean current moving from equator to pole. Generally ocean current moving from equator to pole are warm current. Moving from equator to pole are warm current. Moving from equator to pole are warm current. But what should be the idea? The zone, colder zone and warmer zone. If anything moving from warmer zone to colder zone, it constitutes warm current. If it is moving from colder zone to warmer zone, it is going to be cold ocean current. एग्जाम्पल लिखेंगे क्या? अभी सारा देख लेंगे. एग्जाम्पल लिखने का क्या है? एग्जाम्पल में लिख लीजिए गल्फ स्ट्रीम, ओयाशियो, ना क्यूरोशियो करंट, नॉट ओयाशियो, क्यूरोशियो करंट, ब्राजीलियन करंट, North Atlantic drift. So many currents are there. We'll see it in detail. Okay. Warm ocean current as well as cold ocean current. Cold ocean current. They are moving from colder zone to warmer zone. Colder zone to warmer zone. Generally, not always, generally, current from polar region to equatorial region. Equatorial region, moving from polar region to equatorial region, termed as cold ocean current. Cold ocean current. Cold ocean current. For example, Peruvian current. Peruvian, important है बच्चे, Peruvian current. Californian current. Californian current. We have West Australian current. We have Bangular current. Bangular current. So these are the cold current. Means minor factor. Salinity is minor. हाँ. मैं बताऊंगा, आ रहा हूं, उसी पे आ रहा हूं. पहले जान तो लो कि ओशन करंट. अच्छा, हाँ, Bangular current. Shall we proceed? Another definition is what? There is drift, there is current, and there is stream. Drift, current, and stream. We happen to have three more terms. You will find, is there any difference in all, or they are same? बताइए. So if you see the speed of all these, it ranges from 3.5 kilometer per hour to 10 to 11 kilometer per hour. And especially the streams, they are having higher speed. Drift is a movement of ocean water due to drifting winds, due to prevailing wind. So if water is moving under the influence of prevailing wind, we call it drift. Water moving under the influence of prevailing wind, we call it drift. That is having an average speed of 3.5 kilometer per hour to 4 kilometer per hour. This is what drift. What is important? Influence of prevailing wind. For example, North Atlantic drift. North Atlantic drift. North Pacific drift. West wind drift. West wind drift. किसके कारण है बच्चे ये drift? Because of prevailing wind. Yes, they are continuous in direction, they are continuous in magnitude. Okay, and I will tell you what is the role of North Atlantic drift, North Pacific drift, and West wind drift. Especially the North Atlantic drift prevailing means preventing the icebergs detached from the polar region to come into the trade route. Otherwise बहुत सारे एक्सीडेंट होते है ना, क्योंकि ये क्या करता है, लगातार वेस्ट टू ईस्ट चल रहा होता है. आई विल टेल यू. व्हाट अबाउट करंट? मूवमेंट ऑफ ओशन वाटर, मूवमेंट ऑफ surface water due to rotation of earth, Coriolis force, prevailing wind, salinity, density difference. So these all are the factors. Rotation of earth, Coriolis force, prevailing wind, salinity difference, density difference, isn't it? We call it ocean current. It has a speed of 4.5 kilometer per hour to 9.5 kilometer per hour. या up to 10 km/h. This is going to be the ocean current. It may be warm, it may be cold ocean current. So this is what ocean current. Okay, ocean current. This is ocean current. And many ocean current, when joined, they give rise to large volume of water that start floating, is called as stream. Is called as stream. Stream is much bigger water of river inside the ocean in movement. This is called as stream. Stream. These are the currents. Ocean currents. When many ocean currents joining with each other and they constitute huge water body, many ocean current joining with each other to create stream. For example, the Gulf Stream. Gulf Stream. So these are the differences between stream, current, and drift. Stream, current, and drift. Is it okay? Confusion तो नहीं? चलें आगे. अब आइए डिस्कस करते हैं व्हाट आर द फैक्टर रिस्पॉन्सिबल फॉर ओशन करंट. देखिए, आपकी किताब में कुछ अलग तरह से दिया है, चाहे एनसीईआरटी हो या फिर सविंदर सिंह हो. इन्होंने फैक्टर्स को क्लाइमेटिक फैक्टर, आर ओशनिक फैक्टर, एक्स्ट्रा ओशनिक फैक्टर एंड मॉडिफायर फैक्टर के नाम से दिया है. मैं इसे समझने के स्तर पे थोड़ा सा मॉडिफाई कर लेता हूं ताकि आपकी समझ विकसित हो. एंड आई डिवाइड इट as a major factor. They are also saying major factor, minor factor, and modifier factor. So we are going to have three type of factor. Is it okay? In your book, it has been given major factor, which is within the ocean, outside the ocean, and modifier factor. Okay, and there is a kind of confusion. We are not able to decipher whether evaporation is going to play the role or temperature difference is going to play the role. So we must have a understanding that these are the major factor. If these major factor will be there, minor factor are not going to play any role. Is it okay? Let's find out the factor responsible for factors. There are some major factor. Major factor. They will be dominant one. So I just write dominant factor. Then there is minor factor. Minor factor. Somewhere they are so dominant, but what happens when major factor are what? In a moderate way. Then the minor factor are going to be dominant. Okay. And the third category is what? Modifier. Modifier factor. Modifier factor is responsible for what? First, changing the direction. Changing the direction. It is responsible for splitting of single current into many currents. These are what? Modifier factor. Changing the direction. Is it okay? Changing the direction. Suppose that there is a For example, I'm just giving you modifier factor. One is ocean bottom relief. This is one of the modifier factor. That means what kind of ocean bottom is there? It is going to hinder the flow of the oceanic water. Certainly hinders the flow of the oceanic water. And second modifier factor is what? Shape of the coastline. Shape of the coastline. It is going to change the direction of the wind, like change the direction of the ocean current. Like this is the shape of the coastline. This is what? West wind drift, bringing water like this, and these are going to collide with the west coast of South America, Chilean coast. And then what happened? There is a ocean current generated from here, and that is called as Peruvian current. Peruvian current. So why this Peruvian current is there? Because of the hindrance of the coastline. The shape of the coastline decide the ocean water, isn't it? Another example of shape of the coastline you will find in case of Africa. Try to see Africa. So if you see Africa, there is a continent. क्या नाम है बच्चे? मेडागास्कर. वेरी गुड. तो मेडागास्कर के पास यहां से ईस्ट अफ्रीकन करंट आ रही होती है, and it bifurcates into two branches. One that is called as Madagascar current, another is called as Mozambique current. So who is responsible for this bifurcation? Isn't it? Shape of the ocean, this coastline, shape of the Madagascar. Here you will find Madagascar current, and this is your Mozambique current. Mozambique current. And sometimes this shape of the coastline is playing so dominant role that it reverses all the rules and manuals. अभी बताऊं या बाद में बताऊं? अभी बता दूं? अच्छा तो सुन लो, याद रखना. किसका? ये पेरुवियन करंट बच्चे. अभी 10 बार बनाओगे इसको. पेरुवियन करंट. ना इंश्योर कि इसी क्लास में सबका नाम याद हो जाएगा, सबका नेचर याद हो जाएगा और किसने क्या किया आपको याद हो जाएगा, क्योंकि आपने खुद बनाया है. ठीक है. अच्छा, वी आर टॉकिंग अबाउट द मॉडिफायर फैक्टर. वी टॉक्ड अबाउट पेरुवियन करंट, वी टॉक्ड अबाउट मेडागास्कर एंड मोजाम्बिक. वन करंट आई एम गोइंग टू डिस्कस that is going to defy all other dominant and minor factors, where the coastline is going to play pivotal role. बताऊं? रुक जाओ, आओ फिर से आ जाओ ब्राजील के कोस्ट पे. This is what? Sun Rock Peninsula. है ना बच्चे? ब्राजील का. Here it is equator, 0 degree. Okay. This is northern hemisphere and this is southern hemisphere. और इधर कौन है बच्चे? This side. यहां कौन होगा? हाँ बताओ. अंगोला होगा ना, अफ्रीका वाला पार्ट. बना ही देते. पता नहीं आप देख पाओगे कि नहीं. यही है ना ये देखो यहां पे अंगोला लिखा हुआ, देखो जरा. अंगोला. और ये रहा ब्राजील. अंगोला से इक्वेटोरियल करंट चलती है बच्चे. क्यों चलेगी? मेजर फैक्टर्स हैं. एंड दिस इक्वेटोरियल करंट कम एंड कोलाइड विद दिस सन रॉक पेनिनसुला. दिस इज व्हाट? ऑलमोस्ट 10 to 12 साउथ, अंगोला से ब्राजील तक जाती है, and it collide with this Sun Rock Peninsula, and one branch become the Brazilian current. This is what? Brazilian current. This is Brazilian current. और यहां से कोलिजन होके जो दूसरी ब्रांच जाती है बच्चे ना, वो इक्वेटर क्रॉस करके आगे पहुंच जाती है। ऐसा दुनिया में सिर्फ एक जगह हो रहा कि सदर्न हेमिस्फीयर का पानी ओशन करंट के रूप में नदर्न हेमिस्फीयर में जा रहा है, और कहीं नहीं होता। ओके, सो दिस इज व्हाट नॉर्दर्न ब्रांच ऑफ साउथ अटलांटिक इक्वेटोरियल करंट। साउथ अटलांटिक इक्वेटोरियल, who is playing this role? The shape of the coastline, and the shape of the coastline is defying all dominant factor. कि भाई रोटेशन ऑफ अर्थ हो रहा है तो ऐसे चलेगा, कोरियोलिस फोर्स, अंकल फेरल अपना नियम लगा रहे हैं। यहां कहता है सनरॉक कि भाई इधर जाएगा पानी। सदर्न हेमिस्फीयर वाटर इज कमिंग इनटू नॉर्दर्न हेमिस्फीयर बिकॉज ऑफ द शेप ऑफ द कोस्टलाइन। Is it okay to everyone? Shall we proceed? So we have discussed this modifier factor. बना लो भाई, बना लो, ठीक है। अंगोला 10 to 12 साउथ डिग्री साउथ लैटिट्यूड है भाई। दिस इज व्हाट लैटिट्यूड, 10 to 12 south. Is it okay? So this is what modifier factor. One more modifier factor I will discuss when we discuss the entire ocean current. Fine. Let's come to the major factors. So we discussed this modifier factor. One is ocean bottom relief. We discussed the shape of the coastline, ocean bottom relief. I will discuss when we talk about Irminger current, Norwegian current, and Ranel current. I will tell you who is going to play the role. Further, let's come to the major factor, our dominant factor. Dominant factor. First one is rotation of earth. Rotation of earth. बच्चे, rotation of earth is the dominant factor which is responsible for gyre in the ocean. Gyre means cyclic run of the oceanic water. This is our earth, and you all have this idea. Earth is rotating on its axis from west to east. This is your equator. Okay, so this rotation of earth is taking place from west to east. What happened? The solid part moved together, but liquid in the ocean basin is loosely held. If you take water in your, अगर थाली में पानी लेके आप दौड़ो तो क्या होगा? पानी गिरेगा, पीछे आएगा ना और गिर जाएगा। क्यों? क्योंकि water is loosely held in the basin. It is not maintaining the pace of your speed, and that's why it is lagging behind. It is lagging behind. So earth rotation is from west to east. This is the rotation. So what happened? The water will start lagging behind. So it will start moving in which direction? Try to see. Start moving from east to west in form of surface current. But yes, if earth is like this, तो क्या होता? ऐसे पूरा घूम रहा होता, लेकिन अर्थ ने क्या किया? इसी में कॉन्टिनेंट्स भी रख लिए। सो बिकॉज ऑफ द कॉन्टिनेंट्स अब क्या होगा, वी हैव डिवाइडेड ओशन इनटू पैसिफिक ओशन, Atlantic Ocean, Indian Ocean. These are the major ocean, isn't it? So near equator, the water start moving like this. But because of different ocean surrounded by what? Land mass is going to be divided. So in different ocean, this rotation is also responsible for genesis of Coriolis force. तो यहां दूसरा फैक्टर क्या है बच्चे, पहले ये समझे कि नहीं, रोटेशन ऑफ अर्थ इज गिविंग व्हाट, मूवमेंट ऑफ वाटर फ्रॉम ईस्ट टू वेस्ट, समझ गए, पक्का ना? एंड ड्यू टू द रोटेशन यू ऑल हैव दिस आइडिया दैट देयर इज Coriolis force. Coriolis force. And what is this Coriolis force telling to the horizontal moving anything? Turn towards your right in northern hemisphere, turn towards your left in southern hemisphere. This is your northern hemisphere and southern hemisphere. So what happened? The water is moving from east to west, but it start turning towards its right. It moved towards its right, move towards its right, move towards its right. This is how the water is moving in northern hemisphere, moving towards its right. And what about in southern hemisphere? Water is moving towards its left, towards its left, towards its left, towards its left. So you'll find in northern hemisphere the gyre is clockwise or anti-clockwise? Clockwise. What about here? Counter-clockwise. So why the oceanic current are making this kind of cyclic movement? It is attributed to Coriolis force. And Coriolis force is actually related with rotation of the earth. So rotation of the earth and Coriolis force happen to be the dominant factor for the movement of water, oceanic water. You understood? Is it okay? Coriolis force and rotation of earth. Apart from it, what else? Second one is addition of fresh water. Wherever there is addition of fresh water, there will be less denser water in form of surface current, and water start moving in form of surface current. With respect to surface current, addition of fresh water is going to be the second dominant factor. Okay, so second factor, dominant factor is what? ये लिख लिया, कोई दिक्कत तो नहीं? And the third factor is what? Addition of fresh water. Addition of fresh water. And this fresh water is largely due to rainfall, due to river discharge, and third one is due to melting of glacier. Melting of glacier. These are the three factor. Addition of rainfall कहाँ होगा आपको पता है. रिवर डिस्चार्ज दो जगह आप याद रखिएगा इस पर्टिकुलर टॉपिक के लिए, एक न्यू ऑर्लियंस, एक अमेजन डेल्टा. ठीक है, हाँ बे ऑफ बंगाल में भी है, आएंगे वहां भी आएंगे, लेकिन जो मैं कह रहा हूं याद करने के लिए उसको याद रखिए, सवाल वहीं से बनेंगे. क्योंकि बे ऑफ बंगाल में जो सर्कुलेशन है वो विंड सिस्टम डिसाइड करता है, नॉर्थ ईस्ट मानसून और साउथ वेस्ट मानसून. ठीक है, आने दो वहां पे, अभी चलने दो आराम से. यू अंडरस्टूड दिस? मेल्टिंग ऑफ ग्लेशियर, तो कोल्ड करंट जितनी भी आ रही है बिकॉज ऑफ मेल्टिंग ऑफ ग्लेशियर, और इधर से वार्म करंट जो भी जा रही है इक्वेटर में, रेनफॉल. Is it fine? So please take down addition of fresh water. Addition of fresh water. Addition of fresh water. Either in form of rainfall rainfall either in form of rainfall or melting of glacier or massive river discharge. This decreases the density of water. And water floats in form of surface current. Decreases the density of water and water floats in form of surface current. ठीक है बच्चे? So, addition of fresh water. These are the major factors. And the next major factor is prevailing wind. Fourth one, prevailing wind. Prevailing wind is another major factor responsible for movement of ocean water. Prevailing wind. Okay? Sometimes this prevailing wind is going to act as the dominant factor. Other factors are going to be reversed. Other factor has no impact. In case of Northern Indian Ocean, dominant factor is going to be prevailing wind. In Northern Indian Ocean, if you see, I'm just giving you the map of Northern Indian Ocean. Go for it. The fourth factor, that is what? Prevailing wind, and sometime it is going to make such a huge impact that other factors are not at all working over here. So when there is southwest monsoon, then there is southwest monsoon ocean current. It is responsible for southwest monsoon ocean current, which is moving like this around Africa, Arab, and it is moving around India just along the coastline. This is the ocean current of Northern Indian Ocean. When this is the ocean current of Northern Indian Ocean, when southwest monsoon is prevailing over there. Indeed, you will understand that is from east to west movement is because of rotation of Earth, isn't it? Coriolis force is moving it like towards right, है ना? लेकिन क्या होता है, जैसे ही नॉर्थ ईस्ट मानसून यहां डेवलप हो जाता है बच्चे, नॉर्थ ईस्ट मानसून, what happened? This entire circulation get reversed. कैसे circulation reverse होता है? अभी कैसे चल रहा है बच्चे? This is what? Clockwise, isn't it? And जैसे ही north east monsoon get established, circulation get reversed like this. It is just moving opposite to the ocean current which were moving earlier. It is just the opposite. Gyre. That means you will say, sir, rotation of Earth is still going on, even then this is going to be the current. Answer is yes. Why? Because these prevailing wind systems are so strong that they cause total reversal of the gyre of the North Indian Ocean. This is dominant factor, and this dominant factor is much dominant than all the three factors. तो क्या रोटेशन बंद कर दिया अर्थ ने? आंसर इज नहीं. These seasonal wind systems are so strong that in North Indian Ocean we have reversal of the gyre of ocean current. Reversal of the gyre of ocean. Just imagine. तो कौन सा फैक्टर कहां डोमिनेंट है और कौन सा डिसाइसिव होगा, इट डिपेंड्स कि आप कहां पे ओशन करंट देख रहे हो. In North Indian Ocean, why this is going to be the case? Because of the seasonal wind, seasonal reversal of the wind system. Seasonal reversal of the wind system. If there is northeast monsoon, the gyre is going to be what? Anti-clockwise. And southwest monsoon system, it is clockwise. Here it is clockwise. Clockwise है कि नहीं? समझ लो, देख लो क्लॉकवाइज. टोटल गायर को अगर इसको हटा दो तो दिस इज व्हाट क्लॉकवाइज, इजंट इट? एंड दिस इज व्हाट एंटी क्लॉकवाइज. एंटी क्लॉकवाइज. और मजेदार बात यह है कि नदर्न इंडियन ओशन में देयर इज नो कोल्ड ओशन करंट, सारे वार्म ही वार्म है. याद रखना, ऐसा दुनिया में सिर्फ यही होता है. इज इट ओके? ठीक है, तो बताया था ना. हाँ, क्या चीज? यहां कोल्ड नहीं है. कोल्ड कहां से आएगा? दैट्स व्हाई देयर इज नो कोल्ड करंट. इज इट फाइन? क्यों हो रहा है ये? प्रिवेलिंग विंड आर सो स्ट्रांग. प्रिवेलिंग विंड आर सो स्ट्रांग. क्यों? आपको बताया है मैंने. यहां पे आईटी सीजेड वेल डेवलप्ड है बच्चे. दिस इज व्हाट योर आईटी सीजेड. आईटी सीजेड. क्यों भूल जा रहे हो इसको? आईटी सीजेड. लो प्रेशर डेवलप हुआ है बच्चे बिकॉज ऑफ मैसिव हीटिंग. आईटी सीजेड. हाँ हाँ हाँ, विंड सिस्टम इतना स्ट्रांग है यहां, इसलिए ऐसे ही ओशन करंट चलती है. ठीक है, शैल वी मूव? ओके, सो वी हैपन टू हैव. अच्छा देखो, गायर क्या है? क्लॉकवाइज. वहां बदल रहा है गायर, वहां एंटी क्लॉकवाइज हो रहा है. सारे फैक्टर धरे के धरे रह गए. So we have covered which factor? This major factor or dominant factor. The dominant factor, as well as we have covered the modifier factor. Let's talk about minor factor. Minor factor is what? Salinity difference. You can take down. Minor factor is salinity difference. First one, temperature difference. Second one, salinity difference. Third one, density difference. Density difference. These are the factors which is going to decide the movement of water, but at what place? When the major factor are at rest, they are not working or they are moderate in their nature. उस समय क्या होगे? माइनर फैक्टर वहां पे ओशन मूवमेंट, ओशन करंट के मूवमेंट के लिए रिस्पॉन्सिबल होंगे. सो दीज आर द फैक्टर विच यू शुड अंडरस्टैंड एंड देन यू स्टार्ट द ओशन करंट्स. लेट्स फाइंड आउट द ओशन करंट. पढ़ लेते हैं. नॉर्थ अटलांटिक, साउथ अटलांटिक, नॉर्थ पैसिफिक, साउथ पैसिफिक. नॉर्थ इंडियन ओशन कर ही लिया, साउथ इंडियन ओशन नाम इसका लिख लेंगे अभी, है ना. तो चलिए आइए, ओशन करंट ऑफ नॉर्थ अटलांटिक ओशन. ओशन करंट ऑफ नॉर्थ अटलांटिक ओशन. नॉर्थ अटलांटिक ओशन क्या क्या बनाना होगा बच्चे? हमें बनाना होगा साउथ अमेरिका. लेट्स फाइंड आउट साउथ अमेरिका. नॉर्थ अमेरिका, Okay. We have Greenland. Fine. This is the equator. Here it is Tropic of Cancer. Here it is Tropic of Capricorn. We are actually discussing the ocean current of North Atlantic Ocean. Equator, here it is North Atlantic, and this is what? South Atlantic Ocean. Near equator, from 10 degree north, okay, you have a country Ghana in Africa. This is Africa, Ghana, and from Ghana, water start moving towards from east to west. It is coming from east to west. East to west. This is what called as North Atlantic Equatorial Current. इसका नाम है इक्वेटोरियल करंट. क्या नाम है बच्चे? नॉर्थ एटलांटिक इक्वेटोरियल करंट. North Atlantic Equatorial Current. Why this water start moving towards this side? Because of rotation of earth, because of rainfall. Rainfall हो रहा है कि नहीं? Because of prevailing wind. What is the direction of prevailing wind? ऐसे है ना बच्चे? This is the direction. Trade wind zone में है ना? So net direction is from east to west. So net direction is from east to west. Shall I write rotation of earth, rainfall, and prevailing wind? Shall I write this? Why this North Atlantic Equatorial Current generated? Because of the rotation of earth from west to east. So east to west movement of water. Because of rainfall, addition of fresh water, there will be more surface water, isn't it? Less dense water. And the third one is prevailing wind. The trade wind is what? Resulting the net movement from east to west. So here you are having North Atlantic Equatorial Current. NAEC is what? North Atlantic Equatorial Current. North Atlantic Equatorial Current. Is it okay to everyone? अच्छा ये सीधे चले जाएंगे क्या? अंकल फेरल को तकलीफ होगी बच्चे. अंकल फेरल क्या कहेंगे? किधर मुड़ जा? टुवर्ड्स राइट मुड़ जाएंगे. अच्छा यहीं से देखो, ध्यान से देखोगे तो यहीं अमेजन है क्या? तो यहां एक्स्ट्रा पानी है क्या? कुछ पानी इधर से आया, some water, and you will find one more current generated over here that goes inside the Caribbean island, which is called as Antilles current. It is called as Antilles current. है ना बच्चे? So what is the reason of Antilles current? Extension of North Atlantic Equatorial Current water as well as Amazon discharge. अच्छा बच्चे, अमेजन डिस्चार्ज हुआ तो इज देयर चेंज इन डेंसिटी? डेंसिटी विल बी लेस. सरफेस वाटर स्टार्ट फ्लोइंग इन फॉर्म ऑफ एंटाइल्स करंट. और यही एंटाइल्स है, ग्रेटर एंटाइल्स, कई सारे आइलैंड हैं कैरेबियन में, तो ये उधर से होते हुए निकलेंगे. अच्छा, देयर इज वन मोर रिवर, दैट इज व्हाट? मिसिसिपी, मिसौरी. मिसिसिपी, मिसौरी, ड्रेनिंग वाटर ओवर हियर. क्या नाम बताया था? न्यू ऑर्लियंस. याद है ना? अब यहां एक्स्ट्रा वाटर होगा बच्चे, तो ये कहीं जाएगा. कहां जाता है? यहीं से एक और करंट बन जाती है, नाम है उसका फ्लोरिडा करंट. फ्लोरिडा करंट, दिस इज व्हाट कॉल्ड एज फ्लोरिडा करंट. Who is responsible for this current? Mississippi, Missouri drain. So a warm current or cold current? कोल्ड कैसे? पोल पे पहुंच गए, नालायक, सारी मेहनत पे पानी फेर रहा है, इसको कोल्ड बना रहा है. इट्स वार्म करंट. तो देखो यहां से एक फ्लोरिडा करंट आ गई, एक आ गई एंटाइल्स करंट. एक करंट कौन सा है बच्चे? नॉर्थ अटलांटिक इक्वेटोरियल करंट, है ना. तीन तो ये हो गए, ये भी यहां घूम फिर के आ ही जाएगी. एंटाइल्स करंट भी आके यहां पे मिल जाएगी. यहां अंगोला से कोई पानी चल रहा था, याद करो, बताया था. दिस इज व्हाट? साउथ अटलांटिक इक्वेटोरियल करंट. साउथ अटलांटिक इक्वेटोरियल करंट का एक पार्ट क्या बनाएगा? ब्राजीलियन करंट. और एक पार्ट किधर को भेज दिया जाएगा? ध्यान से देखो, दिस वाटर विल कम लाइक दिस एंड बिकम द पार्ट ऑफ, यहां जो करंट बनेगी उसका. तो कितनी करंट यहां आ गई बच्चे? 4 करंट्स. कहां कहां से आ रही? फिर से एक बार, extension of North Atlantic equatorial current because of Coriolis force and Ferrel towards right. Extension of South Atlantic equatorial current branch which was divided by the sun rock shape of the peninsula. Antilles current and Florida current. कितनी करंट मिली बच्चे? तो अगर करंट ढेर सारी मिले तो क्या बनाती हैं? बनेंगी यहां. कौन सी स्ट्रीम है यहां पे? देखो अपने एटलस में, नाम है इसका गल्फ स्ट्रीम. इट इज व्हाट? गल्फ स्ट्रीम. वार्म या कोल्ड बच्चे? गल्फ स्ट्रीम, है ना. इट्स वार्म करंट, गल्फ स्ट्रीम. गल्फ स्ट्रीम अलोंग द कोस्ट ऑफ नॉर्थ अमेरिका. ये ऐसे ही क्यों चली? क्योंकि शेप ऑफ द कोस्ट लाइन. शेप ने कहा कि भाई यही रास्ता देंगे और रास्ता नहीं मिलेगा. और कोरियोलिस फोर्स, है ना. समझते जाना, अब तुम मेजर माइनर लगाते जाओ जो मैंने बताया है. देयर विल बी नो कंफ्यूजन. हो रहा है क्या कंफ्यूजन? बिकॉज ऑफ कोरियोलिस फोर्स, बिकॉज ऑफ द शेप. यस. एंड देयर इज वन मोर करंट दैट इज कमिंग फ्रॉम द पोलर रीजन. ऐसे आ रही थी, क्या नाम है इसका? लैब्राडोर. क्यों नाम है लैब्राडोर पेनिनसुला? कैसे बनी बच्चे? कैसे बनी? हाउ दिस करंट वाज मेड? कौन बनाया दिस करंट? मेल्टिंग ऑफ ग्लेशियर. बिल्कुल क्लियर कट रहना चाहिए. मैं बोलूं कोल्ड करंट, आंख बंद करके सर मेल्टिंग ऑफ ग्लेशियर. याद कहां करना है? एंटाइल्स में. याद कहां करना है? फ्लोरिडा में. ठीक है. मेल्टिंग ऑफ ग्लेशियर. हु इज रिस्पॉन्सिबल फॉर दिस नॉर्थ अटलांटिक इक्वेटोरियल करंट एंड साउथ अटलांटिक इक्वेटोरियल करंट? साउथ अटलांटिक इक्वेटोरियल करंट यही है बच्चे. ट्रिपल आर नहीं है, RRW. रोटेशन, रेनफॉल एंड विंड. रोटेशन, रेनफॉल, विंड, इसकी बात कर रहा हूं, है ना। एंड दिस कोल्ड करंट, दिस इज व्हाट, लेब्राडोर करंट, लेब्राडोर करंट। ये लेब्राडोर करंट कैसा पानी लाएगी, कोल्ड वाटर, बहुत बढ़िया, ठंडा ठंडा, कूल कूल। और यहीं पे न्यू फाउंड लैंड, यहां पे आके ये पानी क्या होगा बच्चे, मिक्सिंग ऑफ वाटर, वार्म एंड कोल्ड वाटर। यहां डेंस फॉग बनेगा क्या, उस फॉग को क्या कहेंगे, एडवेक्शनल फॉग कहेंगे क्या, पढ़ा है क्या कहीं। अच्छा, whenever there is meeting of cold current and warm current, there is mixing of water taking place. This will create conducive condition, and in this conducive condition there is massive growth of phytoplankton, and phytoplankton is going to be pizza burger for fishes. So you happen to have great fishing zone. You will find great fishing zone like Grand Bank, Saint Pierre Bank, it's over there. So great fishing zone, great fishing zone. Earlier, when there was no technological upgradation, what happened, because of the dense fog, it was not easy to go for fishing, it was not easy for navigation. So in older book, अगर चाचा जी वाली किताब मिली है तो उसमें आप पाओगे कि fishing is very difficult despite of great fishing zone earlier. But now we have upgraded technologies, we have what you can say, satellite communication, so fog is not going to be the determinant to decide the fishing, isn't it? So great fishing zone of the world, Grand Bank, Saint Pierre Bank, etc., near Newfoundland. You remember Newfoundland? What else? When this water, warm water accumulated here, and this is the zone of westerly or not? Westerly, almost 45 north. This meeting point is there. Okay, and now this zone is westerly, so there will be prevailing wind, and that is what, like this, westerly wind. And under the influence of westerly as well as Coriolis force, the water start moving towards west to east. हाँ, तो मूव करा लेते हैं। तो अंडर द इन्फ्लुएंस ऑफ वेस्टर्ली क्या होगा बच्चे, इसको थोड़ा बड़ा कर लेते हैं। Under the influence of westerly and Coriolis force, what happened? There is a drift generated, and that is called as North Atlantic drift. North Atlantic drift. North Atlantic drift. Shall I write here? North Atlantic drift. NAD. NAD, that means North Atlantic drift. Okay. And this North Atlantic drift, when approaching towards North Sea, United Kingdom or Norwegian coast, because of the ocean bottom relief, यहीं से तो है बच्चे, एस शेप का मिड ओशनिक रिज अटलांटिक ओशन का, इट split into 3 ocean current. One is called as Irminger, another is called as Norwegian, and another is called as Rennell current. 3 currents are going to be formed, and of which type, cold or warm? बहुत दम लगा के बोला है कोल्ड, सब ठीक है ना? ये कोल्ड है मूर्खाधिराज, हाँ, फिर से दम लगाओ, सोचो, दिमाग में दम लगाओ। हाँ, मॉडरेट नहीं है, बस 2 ही पूछना है, कोल्ड या वार्म। वार्म रहेगा, ये दल बहुत तेज बदलता है। थोड़ा सोचो बच्चे, देखो बहुत मस्ती में पढ़ना है, बहुत परेशान नहीं होना, लेकिन एक बार जब समझ लो ना तो फिर कंफ्यूज मत होना। तो 2 टाइप्स ऑफ करंट, मॉडरेट करंट बताए थे क्या? तो जबरदस्ती अपनी ज्योग्राफी क्यों डेवलप कर रहे हो, है ना? सो ध्यान से, कैसा होगा बच्चे, कोल्ड और वार्म? वार्म ओशन करंट। एक का नाम है इरमिंगर, है ना, दिस इज व्हाट, इरमिंगर, आई. Another one is Norwegian, another one is Ranel current. I stand for, here I am writing I, that is Irminger current. N stand for Norwegian current, and R stand for Ranel current. Ranel current, है ना बच्चे, इरमिंगर, नॉर्वेजियन एंड रैनल करंट. यस, दिस स्प्लिटिंग इज अट्रीब्यूटेड टू द फैक्टर, क्या बताया था मैंने, यस, टोपोग्राफी, ओशन बॉटम टोपोग्राफी, शेप ऑफ द ओशन बॉटम टोपोग्राफी, इजंट ओके. अच्छा, एक चीज और, अगर जीसी लियोंग पढ़ रहे होगे ना, तो यहां पे एक करंट और दिखाई जाएगी, ऐसे आ रही है बच्चे. इसका भी नाम उन्होंने इरमिंगर रखा है, और इसको उन्होंने कहा है कोल्ड करंट. तो नाम रख सकते हैं भाई, इरमिंगर जगह है, उधर से अगर पोल से जो पानी आ रहा है उसको आप कोल्ड कह लीजिए, इधर से जो जा रहा है उसको हम वार्म कहेंगे. तो बच्चे पूछते हैं सर इरमिंगर करंट शुड वी विल कॉल इट कोल्ड करंट और वार्म करंट. तो इट डिपेंड्स अपॉन द डायरेक्शन. अगेन आई से डायरेक्शन, फ्रॉम विच जोन द वाटर इज मूविंग टू विच जोन. Is it okay? So this Irminger cold current is also there, but do remember it is melting of glacier and is coming towards south. Irminger current, and Irminger warm current is the branch of North Atlantic drift split over here. One is reaching to Iceland. This Irminger is reaching to Iceland. There is the country Iceland over here. और जिस समय ये करंट पहुंच रही है बच्चे, ठंड के समय में सभी सिकुड़ के घर में बैठे होते हैं. इंटायर लैंड इज फ्रोजन, इंटायर पोर्ट्स आर फ्रोजन, देयर इज नो एग्रीकल्चरल एक्टिविटी, नो एनिमल हस्बेंड्री. बट व्हेन दीज वाटर आर रीचिंग ओवर देयर, इट इंक्रीजेस द टेम्परेचर ऑफ द एरिया बाय 15 डिग्री सेंटीग्रेड एंड इट अनफ्रोज द पोर्ट्स. पोर्ट जो ब्लॉक थे वहां की बर्फ को हटा दिया जाता है, and the port become navigable. Norwegian, Finland, France, Sweden, up to Murmansk. Murmansk is a port of Russia. यहां पे है मरमस्क, Murmansk. This is the port of Russia. Get unfrozen. Norwegian port get unfrozen. French port get unfrozen. United Kingdom, यहीं पे है बच्चे यूनाइटेड किंगडम. और यहां पे लोग ईस्टर मना रहे होते हैं, लेकिन ठंड में बेचारे दुबके होते हैं. जैसे ही ये रेनल करंट पहुंचती है नॉर्थ सी में, दिस इज व्हाट नॉर्थ सी, वहां का टेम्परेचर बढ़ जाता है बच्चे, एंड पीपल बिकम हैप्पी. दैट्स व्हाई दिस रेनल करंट इज रेफर्ड एज ईस्टर करंट. इसको कभी कभी क्या कहते हैं आप, ईस्टर current. This is called as Easter current. What are the impact it is going to create? Unfrozen the port, creating conducive warm winter. Means frozen winter था वो warm winter हो गया. It will cause rainfall over there. It will unfrost the port, unfrost the land area get exposed. Lush green grasses get developed, and that will help animal husbandry. Rainfall, open land mass is responsible for what? Agricultural practices that is also going on. People who are not so active because of chilling winter is now active and they are doing their job. So the socio-economic development, the all-out development of Western Europe is attributed to this warm ocean current. Not only this, the warm water reaching to the cold water of North Sea. Cold water है ना North Sea में, and warm water reaching over there, creating moderate situation. There will be growth of phytoplankton. Phytoplankton is the food for the sholas of fishes. it attracts huge amount of fishes over there, so great fishing zone. फिशिंग कर लिया, एग्रीकल्चर कर लिया, एनिमल हस्बेंड्री, क्रॉस्ट फ्री पोर्ट हो गए, बिजनेस कर लिया, तो सोशियो इकोनॉमिक डेवलपमेंट नहीं होगा क्या? आंसर इज यस. सो द सोशियो इकोनॉमिक डेवलपमेंट ऑफ वेस्टर्न यूरोप इज अट्रीब्यूटेड टू द ओशन करंट. डिस्कस विथ एग्जाम्पल. कैन यू डिस्कस इट इन 150 वर्ड? ये मैप जाएगा, याद रखिएगा. इरमिंगर कोल्ड करंट भी है, वार्म करंट भी है, बट उसकी डायरेक्शन बदल जाएगी. आप देखेंगे ना, अभी जब जाएंगे जीसी लियोंग में, विल फाइंड इरमिंगर एज अ कोल्ड करंट एंड इरमिंगर एज अ वार्म करंट. इज इट ओके? अब क्या होगा बच्चे? हाँ हाँ हाँ. क्यों? तुम लैंड हो मान लो, और तुम्हारे किनारे एक बर्फ की बनी गुड़िया लाके रख दी जाए, उसके कारण तुम ठंडे होगे कि नहीं, ये बताओ? होगे. तो अगर वार्म वाटर आ रहा है तुम्हारे आसपास, अच्छा कूलर से ठंडा हो जाता है कि नहीं? क्या होता है कूलर? व्हाई इट इज डिफरेंट फ्रॉम फैन? समझ गए? मॉडरेटिंग इफेक्ट 25 बार बता चुका हूं तुमको. मेरी टाइम क्लाइमेट. अब की पूछोगे तो खिड़की ये बंद है, यहीं से फेंकूंगा बाहर. समझ? बेटे जब कभी भी सराउंडिंग इज गोइंग टू बी अफेक्टेड बाय द टेम्परेचर ऑफ वाटर. इफ वाटर इज गोइंग टू हैव कोल्ड टेम्परेचर, देयर विल बी डिफरेंट इफेक्ट. वही बताने जा रहा हूं. एंड वार्म वाटर विल रीच, सर्टेनली देयर विल बी हीटिंग इफेक्ट, देयर विल बी मोर इवेपोरेशन. इवेपोरेशन ज्यादा होगा तो रेन विल बी हैप्पी, देयर विल बी रेनफॉल. इजंट इट? बता चुके हैं, फिर भी ऐसे सवाल पूछते हो आप. वो वाला ऐड नहीं देखा, पान पसंद वाला? कल से यहीं पे एक वो रखूंगा, पानी का वो. तुम हंस क्यों नहीं रहे हो? अच्छा समझ में आ रहा है ना तुम्हारे? याद रखना, दिस इज द मोस्ट सिंप्लीफाइड वर्जन जो मुझे, जिसमें कोई प्रॉब्लम नहीं दिखती. अदरवाइज देयर आर सम कंफ्यूजन लिखने में नहीं किया है लोगों ने, हम समझने में कर जाते. दैट्स व्हाई आई एम पुटिंग दिस मच एफर्ट, बिकॉज दे आर नॉट गोइंग टू आस्क क्वेश्चन कि नॉर्थ अटलांटिक ड्रिफ्ट इज वार्म करंट और कोल्ड करंट. नहीं, वो पूछेंगे कि नॉर्थ अटलांटिक ड्रिफ्ट के इंपैक्ट क्या क्या है, उसमें वो सारे इंपैक्ट बताएंगे जो स्प्लिटिंग के बाद हो रहे हैं, है ना? तो you need to remember. Further, there will be accumulation of water over here. Okay, fine. This is near North Sea. This water and compare this water, equatorial. What is the temperature at equator? हाँ, 27 है ना? Good. 27 डिग्री सेंटीग्रेड. यहां पे क्या टेम्परेचर एक्सपेक्ट कर रहे हैं? लेस देन 27 और मोर देन 27? वेरी लेस देन 27. 10 डिग्री सेंटीग्रेड, 5 to 10 डिग्री सेंटीग्रेड. अच्छा अगर यहां पे पानी एक्यूमुलेट हो जाए सरफेस पे, तो ये यहां से कहीं चलना शुरू करेगा. किधर आएगा बच्चे? इट स्टार्ट मूविंग टुवर्ड्स साउथ. Start moving towards south, towards equator, and this will constitute current that is called as Canary current. Canary current क्या है बच्चे? Canary current कोल्ड या वार्म? बताओ, कोल्ड या वार्म? सच में? कैसे पता चल गया? हाँ, एक ही चीज आपको ध्यान रखनी है, कौन कहां से आ रहा है, काम बन जाएगा. दिस इज व्हाट? कैनरी करंट. कैनरी करंट इज कोल्ड करंट, इजंट इट? कैनरी करंट इज कोल्ड करंट. अच्छा कोल्ड करंट आएगी, ये अफ्रीका है ना, अफ्रीका के वेस्ट कोस्ट के टेम्परेचर को क्या करेगी? इट विल डिक्रीज. व्हाट हैपेंड टू द रेट ऑफ इवेपोरेशन? Decrease. What happened to the humidity of the air? Decrease. What happened to the rainfall? डिक्रीज। सो अगर डिक्रीज रेनफॉल होगा बच्चे तो यहाँ रेनफॉल हो पाएगा? नहीं होगा, बहुत कम होगा। तो यहाँ पे क्या डेवलप होना चाहिए? डेजर्ट होना चाहिए। ठीक है, देखो जरा यहाँ कोई डेजर्ट है क्या? क्या नाम है? बेसहारा सहारा, दुनिया का सबसे बड़ा डेजर्ट। क्या यहाँ सब ट्रॉपिकल हाई प्रेशर बेल्ट भी दिखाई पड़ रहा है क्या आपको? सब ट्रॉपिकल हाई प्रेशर बेल्ट, थिंकिंग ऑफ विंड, removing all the possibility of rainfall, sinking of wind. Second is what? Cold ocean current. And third is what? Continentality effect. These three factors are responsible for formation of desert at the western margin. है ना? Western margin. समझ गए सारा गायर? हाँ हाँ बिल्कुल। आपको जोन देखना है बच्चे। इक्वेटर पे पानी कैसा आ रहा है? ठंडा पानी आ रहा है। कहां से आ रहा है? पोल साइड से आ रहा है, तो कोल्ड करंट होगा। इज इट ओके? इसको थोड़ा बड़ा कर दें, आप लोगों को चाहिए होता है ना? कोई बात नहीं, आपने लिखा है, बाकी हो सकता है जरूरत हो किसी को। आपकी श्रद्धा। लिखिए, नॉर्थ ओशन करंट ऑफ नॉर्थ अटलांटिक ओशन, ओशन करंट ऑफ नॉर्थ अटलांटिक ओशन। फर्स्ट, नॉर्थ अटलांटिक इक्वेटोरियल करंट, नॉर्थ अटलांटिक इक्वेटोरियल करंट, शॉर्ट में लिखेंगे हम लोग नॉर्थ अटलांटिक इक्वेटोरियल करंट। इट इज ड्यू टू फर्स्ट रोटेशन, रेनफॉल and prevailing wind. Rotation, rainfall and prevailing wind. Develop between 0 to 10 degree north. Developed between 0 to 10 degree north. Zero to 10 degree north from Ghana coast to Brazil coast. From Ghana coast to Brazil coast. It turns towards right. It turns towards right under the influence of turns towards right under the influence of, क्या लिखूं बताओ? कोरियोलिस फोर्स, अंडर द इन्फ्लुएंस ऑफ, बताओगे नहीं तो नहीं बोलूंगा। अंडर द इन्फ्लुएंस ऑफ कोरियोलिस फोर्स। ठीक है। एंटाइल्स करंट, एंटाइल्स करंट जनरेटेड ड्यू टू, कहां तक? जहां बताया है वहीं तक, आगे लिखो। एंटाइल्स करंट, एंटाइल्स करंट, it is generated due to extension of North Atlantic equatorial current, North Atlantic equatorial current and Amazon freshwater discharge. Freshwater discharge. Amazon freshwater discharge. Okay. Florida current. Florida current. It is generated due to massive river discharge of Mississippi, Missouri. Massive river discharge of Mississippi, Missouri, near New Orleans. New Orleans. Mississippi, Missouri, near New Orleans. All these three current east to Florida coast, east to Florida coast, all these three currents east to Florida coast merges with each other, along with branch of, इसको अंडरलाइन करना, along with branch of South Equatorial Atlantic current. South Atlantic Equatorial current कैसे ब्रांच बनी, याद है ना? मार्केट स्टार एंड वहीं ब्रैकेट में लिखिए शेप ऑफ द कोस्ट. याद आ रहा है कि नहीं? ओके, क्या लिखा सेंटेंस, क्या लिखा? ऑल द थ्री करंट मर्जेस ईस्ट टू फ्लोरिडा कोस्ट along with branch of South Atlantic Equatorial current and they constitute Gulf Stream. They constitute Gulf Stream. Okay. Gulf Stream merges with Labrador current. Gulf Stream merges with Labrador current near 45 degree north. Near 45 degree north. Gulf Stream merges with Florida current, Labrador current at 45 degree north. Labrador current is cold current. Labrador current is cold current. Generated due to, क्या लिखेंगे? Melting of glacier. That's enough. मेरा काम हो गया, अब तुम लोग समझ गए. Melting of glacier. ठीक है, अब इसके इम्पैक्ट लिख लेते हैं बच्चे. कोल्ड करंट, वार्म करंट जहां भी मिलेगी, इट विल क्रिएट कंड्यूसिव टेम्परेचर. सो ड्यू टू मीटिंग ऑफ contrasting current, due to meeting of contrast current, conducive condition generated for luxuriant growth of phytoplanktons. Phytoplankton attracts huge shoals of fishes. Phytoplanktons attracts huge shoals of fishes, hence creating shoals, group of fishes लिख लो भाई, या fishes attracting more fishes लिख लो. Creating great fishing zone of the world. For example, Grand Bank, Saint Pierre Bank, ग्रैंड BANK, SBI है ना, स्टेट बैंक, वही बैंक. ग्रैंड बैंक, ग्रैंड. अभी जो तुम लोग करोगे होली, तुम लोग की शक्ल देख के लग रहा है हमें भी परेशान करने वाले हो. रंगे तो ठीक नहीं होगा, बता. ग्रैंड बैंक, समझ गए? गुड. सेंट पियरे बैंक. सेंट पियरे बैंक. ठीक है बच्चे. अब आगे, इसके आगे 45 नॉर्थ के पास, दिस इज द जोन ऑफ वेस्टर्ली एंड ट्राई टू सी द डायरेक्शन ऑफ वेस्टर्ली, इट विल ड्रैग टुवर्ड्स ईस्ट. और कोरियोलिस फोर्स कहेगा चल आगे चल, है ना? सो देयर इज जेनेसिस ऑफ नॉर्थ अटलांटिक ड्रिफ्ट. पैरा चेंज करिए एंड टेक डाउन. नॉर्थ अटलांटिक ड्रिफ्ट जनरेटेड, नॉर्थ अटलांटिक ड्रिफ्ट जनरेटेड due to prevailing wind in bracket westerlies, due to prevailing wind westerlies, है ना वेस्टर्ली का जोन, prevailing wind westerlies as well as Coriolis force. Surface water start drifting towards north east, towards northeast. Northeast, near United Kingdom, North Atlantic drift, North Atlantic drift splits into three warm ocean current. They are, first, Irminger current, Irminger current, Irminger current डैश करके लिखिएगा. It brings warm water, it brings warm water to Iceland coast, creating pleasant weather during chilling winter. Next, Norwegian current, Norwegian current, Norwegian current. Norwegian current. ठीक है बच्चे? It moves towards north and northeastward, towards north and northeastward up to Murmansk, up to Murmansk, that is the port of Russia. Okay, Murmansk, that is Russia. अभी collectively सबका बता दूंगा ना, अब सबका अलग अलग बताऊं. Third one is what? Rannel current, Rannel current reaching to the North Sea, reaching to the North Sea along United Kingdom. All the three currents are responsible for, all the three currents are responsible for, first, frost pre-ports, hence boost navigation. Earlier navigation was not possible. Second, warm, pleasant weather. Warm, pleasant weather. Third, winter rain. Winter's rain. Fourth, land get opened. It helps in agriculture. Fifth, lush green meadows. Meadows are developed that supports animal husbandry. And basically this area is having what? Grape cultivation, wine cultivation, and beverages industry. वाइन वगैरह बनाते हैं, वाइन कल्टीवेशन कह रहा हूं, ग्रेप कल्टीवेशन that support wine industry. So because of this, what you can say, warm water, ripening of grape is going to be fasting. So faster rate of ripening of grape, or you can say it helps in ripening of grape. So it supports beverages industry. So if you see the all-round development over here, so the socio-economic development, of Western Europe is attributed to these three warm current: Rannel current, Irminger current, Norwegian current. और यही नोट लगा दो, there is Irminger cold current, but the direction is different. ये आपकी अंडरस्टैंडिंग के लिए होना चाहिए. So don't get confused कि Irminger warm or Irminger cold. It depends upon the direction. Whether it is coming from pole, then it is cold. When it is going towards pole, it is warm. Is it okay? Okay. Now, and fishing zone भी लिख लो भाई. 7th. Fishing zone बनेगा कि नहीं? Fishing zone in North Sea. Fishing zone in North Sea. You'll find over. क्या चीज? नोट समझने के लिए था कि इर्मिंगर कोल्ड करंट भी है. जीसी लियोंग पढ़ोगे ना तो आपको एक कंफ्यूजन हो सकता है, क्योंकि मेरे बच्चों को होता है कि सर इर्मिंगर को क्या कहें, उसमें तो कोल्ड करंट दिया है, आपने वार्म लिखाया है, तो नाम है बच्चे, बस देखना है डायरेक्शन क्या है. इफ इट इज मूविंग फ्रॉम इक्वेटर टू पोल, we call it warm current. If it is moving from pole to equator, cold current. That's it. You understood? Okay. Further, अब Canary current की बारी आई. लिखो. The accumulated water near North Sea start floating towards south in form of cold ocean current. We call it Canary current. There is a Canary island over here now, so the name has been given Canary current. Canary current brings cold water to the west coast of Africa. it reduces it reduces it reduces the temperature. It reduces the temperature. Hence the rate of evaporation. Hence the rate of evaporation. Hence the rate of evaporation. Okay. Less evaporation reduce the rainfall. And rainfall further reduced by subtropical high pressure belt. Further reduced by subtropical high pressure belt, presence of subtropical high pressure belt, and continentality effect. Continentality effect. And continentality effect. These are the reasons prevailing at western margin of each continent. These are the reasons prevailing at western margin of each continent, and hence hot deserts are developed. Hence the hot deserts are developed. Hence the hot deserts are developed. ठीक है, तो दुनिया में जितने आपने हॉट डेजर्ट देखे हैं, they are developed at western margin below subtropical high pressure belt. Continentality effect, and one major factor is what? Cold current. Whether it is Sonoran desert, Mojave desert, Mexican desert, you will find Californian current over there. When you see the Peruvian current, Atacama, Peruvian desert, Atacama desert, there will be Peruvian current. You will see Namib and Kalahari desert, you will find Benguela current in case of Africa. In West Australian current, again going to be cold current, and western margin of Australia have deserts. So these three conditions are required for desert development. Not required, they are prevailing at western margin, and that's why western margin of each continent in the subtropics are having what? Deserts, hot deserts. Is it okay to everyone? So this is Thar के केस में continentality is going to play the role. Yes, indeed there is no cold current, but the continentality is there and subtropical high pressure belt is there. Okay. Continentality effect 26वीं बार समझाने जा रहा हूं तुम्हें. हाँ, मेरीटाइम क्लाइमेट और कॉन्टिनेंटलिटी इफेक्ट एक साथ बताया था. तुम क्यों बार बार कंफ्यूज होते हो? If continent is going to be broader, so the wind which is taking the moisture from the ocean and moving towards the west, it will shed all the moisture, and by reaching up to the extreme of the continent, there will be no moisture. जो along the coast you have maritime climate, you have the rainfall, and away from the coast in the extreme you have very less rainfall, 27th times. अब तुम सोच लो, अब समझ गए? कल भी यही पूछा था आपने. हाँ, और अभी भी नहीं समझोगे, परसों अगर पूछे तो फिर समझ लेना, मैं दूसरी तरह से भी समझाऊंगा. पक्का? अब समझ गए होगे ना? थोड़ा डराना भी पड़ता है तुम लोग को, नहीं तुम लोग. चलें आगे. लेट्स कम टू द साउथ Atlantic Ocean. In South Atlantic Ocean, याद है ना ये वाला? ये याद रखना, ये आपकी किताब में नहीं है. गल्फ स्ट्रीम कैसे बनी है, क्या पता यही दे दे. गल्फ स्ट्रीम, which of the following streams are currents are making Gulf Stream? एक ऑप्शन होगा ब्रांच एक्सटेंशन ऑफ सदर्न अटलांटिक इक्वेटोरियल करंट। पक्का होगा, कभी गल्फ स्ट्रीम पे सवाल पूछा इन्होंने तो। चलिए आगे देखते हैं। And this is the zone of what? Westerlies. So you'll find that the westerlies is continuously blowing in southern hemisphere. And due to this continuous movement, unblocked movement and profound westerly, they have created a global ocean current which we call west wind drift. This is what? West wind drift. West wind drift. So it is continuous on entire globe, means not only in Atlantic Ocean, it is reaching into the Indian Ocean, it is in Pacific Ocean. So entire west wind drift zone is there, okay, in the zone of westerly. And this is what? So profound, you know, westerly, furious, roaring 40s, furious 50s, shrieking 60s, etc. So they are very profound. That's why they are dragging the water, and hence there is a continuous drift present on entire globe in each and every ocean. So this is what? West wind drift. Again, you all have this idea, there will be equatorial current, and that is what? South equatorial current. South Atlantic equatorial current. What is the reason behind it? R, W. वही reason होंगे. कहां से बच्चे? Here it is Angola to Brazil, है ना बच्चे? एंड ब्राजील में आकर के एक ब्रांच तो चली जाएगी जिसकी कहानी हम लोग पढ़ चुके हैं, एंड अनदर ब्रांच इज गोइंग टू बी लाइक दिस, एंड दिस इज कॉल्ड एज ब्राजीलियन current. This is Brazilian current. What about Brazilian current? Why Brazilian current is there? Because of Coriolis force, because of extension of South Atlantic equatorial current. Is it okay? And this Brazilian current come over here meeting with a cold current that is called as Falkland current. Here you will find cold current, that is Falkland current. This is Falkland current. Falkland current. Some cold water from west wind drift start percolating towards north in form of Falkland current, which is cold current. And once cold current and warm current is meeting, it will create conducive condition or not? So fishing zone होगा कि नहीं? तो इधर चिली, अर्जेंटीना fishing zone है ना? अब क्या होगा बच्चे? This water, this Brazilian current is having warm water ना? So warm water near Brazilian coast will increase evaporation, and due to evaporation there will be more rainfall. So east coast of Brazil is going to have more rainfall, and that's why it is going to support the agriculture over there. Agriculture मतलब सारा कुछ तुम्हारा ही किया धरा है. हाँ अच्छा ठीक है, अभी डराने के लिए क्यों ला दिया? अभी तो एग्रीकल्चर करा लेने देते. सो इन ब्राजील हाँ नहीं अब 2 बजे तक चलनी है. अच्छा इसके बाद जाओगे या पढ़ोगे और देर तक? ऑप्शनल नहीं है आपकी आज. देयर इज नो ऑप्शनल. दैट्स व्हाई आई एम मींस आस्किंग दिस क्वेश्चन. क्या पता थोड़ी देर में तुम्हारा मन हृदय परिवर्तन हो जाए. तो क्या चाहते हैं, थोड़ा एक्स्ट्रा कर लें? पक्का? कोई किसी को दिक्कत तो नहीं? किसी की होली में खलल तो नहीं पड़ रहा? चलेगा? नहीं 5 बजे तक नहीं पढ़ाऊंगा, लेकिन अगर मैम रहती तो पढ़ते कि नहीं? कुछ खाए नहीं, बीच में गैप दे दूं, गैप के बाद 5 बजे तक मैं छोड़ दूंगा। अच्छा चिंता मत करो, मैं नहीं चाहूंगा। थोड़ा सा ये कवर कर लेते हैं ताकि फिर केवल नाम ही बता दूं तो आप समझ जाएं। सो ब्राजीलियन करंट, इट इज वार्म करंट ब्रिंगिंग वार्म वाटर टू ब्राजीलियन कोस्ट. Warm water will increase the temperature. Temperature increase will increase the evaporation. Increased evaporation will give rainfall to the east coast of Brazil. And hence the Brazil is known for its agriculture, plantation agriculture, coffee production, sugarcane production, rice production. इसके लिए ब्राजील जाना जाता है. So this Brazilian current help in agriculture or not? Answer is yes. This Brazilian current and Falkland current creating fishing zone over here. उसके बाद ये पानी इसी वेस्ट विंड ड्रिफ्ट से मिलके आगे पहुंचता है बच्चे, और अफ्रीका के कॉन्टिनेंटल शेल्फ से टकरा करके यहां से एक कोल्ड करंट बन करके अफ्रीका के किनारे किनारे इक्वेटर तक पहुंचता. एंड दिस इज कॉल्ड एज बेंगुला करंट. दिस इज कॉल्ड एज बेंगुला करंट. कोल्ड या वार्म? कहीं से वार्म भी सुनाई पड़ा. कोल्ड या वार्म? वार्म होगा. पोल इधर है, उल्टा लटका देंगे तुम्हें. पोल इधर है, साउथ पोल. जनरली तुम वही वाला देख रहे हो, ये साउथ सदर्न हेमिस्फीयर है, बहुत कंफ्यूज रहता है. ठीक है बच्चे, ये साउथ पोल, पोलर रीजन से इक्वेटोरियल रीजन, इट इज गोइंग टू बी कोल्ड करंट. मजा भी आता है तुम लोग को पढ़ाने में. ठीक है, दिस इज व्हाट कोल्ड करंट. ओके, सो कोल्ड करंट विल रिड्यूस द टेम्परेचर. हाँ हो जाएगा, कहानी खराब. तो देखो कहाँ है, यहाँ पे कुछ है क्या? डेजर्ट्स हैं क्या? देख लो यहाँ, नामीबिया डेजर्ट, कालाहारी डेजर्ट, यू विल फाइंड ओवर हियर. नामीब एंड कालाहारी. नामीब एंड Kalahari deserts. Why? Because of cold current. And indeed it is subtropical high pressure belt too. Okay, Namib and Kalahari desert you will find in the west coast of Africa. And this west wind drift will come into the Indian Ocean. It will come into the Indian Ocean, है ना? इंडियन ओशन में भी ये आएंगे और फिर पैसिफिक में भी जाएंगे. So this is end of the topic of what? Oceanic current in Atlantic Ocean. Is it okay? Oceanic current in Atlantic Ocean. ये हाँ, यहां से पानी जो है ना बच्चे, देयर विल बी सम डिफरेंस. यहां पे वार्म, ये कोल्ड वाटर है ना, कोल्ड वाटर. So it start moving towards south, moving towards north, not south, towards north in form of Falkland current. Melting of glacier होगा ना, जैसे उधर हो रहा था, तो यहाँ भी होगा ग्लेशियर. तो फ्रेश वाटर ऐड होगा, फ्रेश वाटर ऐड होगा तो वो किधर जाएगा. ठीक है. So whenever there is cold current, it is because of addition of fresh water due to melting of the glacier. Yes. ठीक है, आगे चलें बच्चे. इंडियन ओशन पढ़ लेते हैं, क्योंकि नॉर्थ इंडियन ओशन तो आपने पढ़ ही लिया है, साउथ इंडियन ओशन पढ़ना बाकी. आइए, क्या अब इसमें लिखने का क्या जरूरत है? कोल्ड कर, हाँ लिखने की जरूरत क्या है? कोल्ड करंट क्या कर रही है, वार्म करंट क्या कर रही है, वही करेगी ना, नाम बदलना है. चलिए आइए, ओशन करंट ऑफ इंडियन ओशन. Ocean currents of Indian Ocean. Ocean currents of Indian Ocean. Okay. So we all have this idea that when there is southwest monsoon, then in this case, Indian Ocean has a gyre, North Indian Ocean has a gyre like this. It is what? Clockwise gyre, clockwise gyre, clockwise circulation in Indian Ocean during the southwest monsoon. Fine. Why these seasonal winds are so strong over here? That's why this kind of gyres is there. And when there is reversal of this monsoon wind, and that is what? Northeast monsoon. That is what? Winter monsoon. Then the gyre get reversed, and you will find that the motion of this water is going to be reversed like this. And here you will find that the movement is like this. So you will find the total reversal of the wind as well as ocean current in North Indian Ocean. The southwest monsoon season oceanic current is called as southwest monsoon ocean current, which is flowing in the month of what? June to September, isn't it? It is flowing in the month of June to September. And what happened to the northeast monsoon current, ocean current? It is what? Winter monsoon. From means October onwards, this is going to be the gyre. So in winter season, you will have this gyre in the Indian Ocean. What about in Southern Indian Ocean? In Southern Indian Ocean, you will find equatorial current, South Indian Ocean equatorial current moving from west coast of Australia to east coast of Africa. And then it turns towards its left. होगा कि नहीं? बोलो. It turns towards its left like this in form of East African current. But you will find one landmass over here. What is it? Madagascar. So due to Madagascar, what happened? It split into two ocean currents. One is called as Mozambique current, moving through Mozambique channel. Another one is called as Madagascar current. Mozambique current and Madagascar current. यहाँ लिख लीजिए इसको. In Southern Indian Ocean, South Indian Ocean equatorial current get established from South Indian Ocean equatorial current established from west coast of Australia, west coast of Australia, west coast of Australia to east coast of Africa, east coast of Africa, between 0 to 12 degree south, between 0 to 12 degree south. It turns towards its left. It turns towards its left due to अच्छा ये क्यों बना, ये इक्वेटोरियल करंट RRW, shall I write here? Rotation, rainfall and prevailing wind. Okay, this is what Madagascar, and it rotate towards its left under the influence of Coriolis force, under the influence of Coriolis force and shape of the coastline, shape of the coastline. It divides into two branch due to Madagascar. This is also called as Malagasy current. पुराना नाम है बच्चे, Madagascar and Mozambique current. Mozambique current. Basically, Mozambique is a country. You will see Mozambique, Zambia, Zimbabwe over there. So you'll find this South African country, Southeast African country. You will go there. So Mozambique channel. This is what Mozambique channel. So this Madagascar current being warm, Mozambique being cold, warm. बताओ, फिर भी चेहरा warm होगा तो बोलो ना, मैं भी तो गलत बोल सकता हूँ. So both are warm current. So this will bring warm water to Madagascar coast, Mozambique coast. Will it cause rainfall? Will it support agriculture? Answer is yes. तो यहाँ प्लांटेशन एग्रीकल्चर होता है, दुनिया भर के कॉन्डिमेंट्स है ना. So lot of agricultural activity in this region, Eastern African region. Both current meets with each other and form Agulhas current. Forms Agulhas current. Agulhas current. And इसके ठीक साउथ में क्या चल रहा है बच्चे? There is west wind drift which is moving like this. This is west wind drift. वही है because of the westerlies. West wind drift because of the westerlies. Is it okay? West wind drift. This warm water become the part of west wind drift और इधर जाके ऑस्ट्रेलिया का जो कॉन्टिनेंटल शेल्फ है उससे टकराता है ये पानी बच्चे. एंड देयर इज अ कोल्ड करंट and its name is West Australian current. This is what? West Australian current. West Australian current. अब जरा देखो ऑस्ट्रेलिया खोल के. Western part of Australia is having deserts. है ना? Great Sandy Desert, Victoria Desert, Simpson Desert. So many deserts are there. Is it okay? So this is cold current. Cold current. Yes. So this is the ocean current of Indian Ocean. South Indian Ocean. In Southern Indian Ocean, we happen to have cold current. Is it okay? And in Northern Indian Ocean, you will find special kind of reversal of the current because of the prevailing wind. Is it fine? So we have covered two. 10 मिनट दो तो पैसिफिक भी कर दूं. हाँ, बना लीजिए. क्या ख्याल है? नहीं, आप तो लेट से भी आए हैं। हाँ, मैं हट ही जाता हूं, मेरी जरूरत क्या है, मैं निकलूं क्या? तुम लोग डायग्राम बनाओ। Is it okay? So thank you very much for today and wish you all very happy होली। खूब अच्छे से मिठाई विठाई खाएं और रंग वंग ज्यादा ना खेलें, अच्छी बात नहीं होती। हाँ, चलिए, थैंक यू वेरी मच, हमें पता है। बंद कर।